Now let us consider the following problems given in Shift 2 GATE 2026 Computer Science in discrete mathematics subject. First question, this is from logic, 1 mark question, MCQ. MXY means X knows Y, and we need to convert the following statement into predicate. So there is a person who does not know anyone else, but that person is known by everyone else. So this person does not know anyone else, but everyone else knows him. So that is the statement. And if you observe the options, there is MXY means X knows Y, MYX means Y knows X. See, MXY means X knows Y, MYX means Y knows X. That is the idea. Okay. Now we need to identify. So which one is correct? Now if you see the first option, there is a Y for every X. Of course, X and Y are different. So here what is happening? Every X knows Y, but this Y does not know X. So that is exactly what this particular statement is saying. So option A is straightforward correct. That is, you want, okay, here this person is Y, this is Y, Y is a single person or some person. So this person, and you take any other person other than Y, every other person knows Y, that is X knows Y, that is correct, and Y knowing X is wrong, so negation of that. So this is the correct option. And if you see the second option B, he is talking about everyone for someone, but you want someone for everyone, so this option is wrong. C option, someone for someone, that is why it is wrong. And D option, for everyone for everyone. So everyone, see, it is not there is a person, every person, okay, not known by everyone, but everyone, every other person knows it. So he is talking about everyone. But what you want, some for everyone you want to say. Obviously A is correct answer, B, C, D are wrong options. The next question, MSQ from relations topic for 1 mark. Let R be a relation on set of this integers 1 to 10, where x, y belongs to R if the product of x and y is square of an integer. Which of the following properties are satisfied by R? So here we are saying that x is related to y if and only if x into y should be square of some integer. If it is square of some integer, then we say that x and y are related. So here the set is 1 to 10, and you want, if you take two numbers, if you multiply, that product must be square of an integer. Now maximum you are having 10, so maximum square of an integer 10 square 100. So the possible squares are 1, 4, 9, 16, 25, 36, 49 and 64, 81, 9 nines 81 and 100. So what are the order pairs which gives square 1? This one they should give. 1 can give you 1. 4 means either 1 4 या 4 1 will give you, या 2 2 order pair will give you. That is product of these two number is square of a number. Then 9 means you can consider 3 3, yeah 1 9 9 1 also you can consider. So if you take the numbers, it should be square of a number. The product of those numbers must be square of a number, right? See, because maximum you are having 10, 10 into 10, 100. Nothing will go beyond that. Obviously, 10 maximum, 100 is the possibility. So I am just writing for that. For 16, it is 116 is not possible. Then 2882 is possible. Then 44 is possible. Then for 25, it is 55 only. For 36, it should be like, 66 is anyhow there. Any other things possible for 36? 4 9s, 9 4s. Then 49, it is 7 7s, 49, 64, 8 8s. Then any other possibility? I don't think so. Okay, no other possibility. Then 9 9, and it is 10 10. So these are the order pairs which are belonging to your relation. Now he is asking what type of relation is this? Okay. So obviously 1 1 2 2 3 3 4 4 5 5 6 6 7 7 8 8 9 9 10 10 are present. So it is reflexive. Without that also you can verify, sir, because you take any number into any number, obviously it is square of a number. That means x is related to x. So it is reflexive generally. See why I written this particular order pairs here. Generally the condition may be not satisfied, but for this particular finite set, sometimes some condition may be satisfied, so you have to be very careful, right? Then for symmetric, obviously if x into y is square of a number, obviously y into x is also same square of the number, so symmetric is satisfied. You can see here 1 4 is there, then 4 1 is there, 1 9 is there, then 9 1 is there. And because of the non-symmetry, AB, BA not equal, but symmetry is satisfied, then anti-symmetry will not be satisfied. So reflexive satisfied symmetric means here, because 1 4 4 1 both are related, 1 is related to 4, 4 is related to but 1 is not equal to 4, therefore anti-symmetric failed. Now transitive, generally for x into y is equal to square of a number, transitive may fail. Generally transitive may fail because x into y may be some k square, y into z may be some m square. If you multiply them, like x into y square into z is nothing but km whole square, and here x into z is equal to km by y whole square. But this km by y whole square, because km by y need not be always integer, it may fail generally. But in this case, you will not get that particular case, my dear friends. So here transitivity, because it is a restricted set, though the pairs which give you A, B, B, C, then A, C will be present here. You can check like 1, 4 is there. So 1, 4 is there, 4, 1 is there means 1, 1 is there. That is anyhow there. 1, 4, 4, 9. 1, 9 is also available in this. But when you are going for big numbers, then that may be a failure case. But here, because of the finite set, the transitive. So most bigger twist in the story is about transitive. So transitive is also satisfied. So A, B, C are correct here. A, B, C are correct. The next one, this is one very interesting question. Actually, Jaccard coefficient they use for similarity measure. It is like one of the similarity measure, okay, to find the similarity between some values or some vectors, something. So generally in recommender systems in other places they use this particular Jaccard coefficient. See, the idea of Jaccard coefficient is he defined here. You don't have to worry too much about it. He given a simple definition. Jaccard coefficient between two sets is defined as ratio of size of intersection of the two sets to the size of union of the two sets. So Jaccard coefficient is actually defined as, suppose AB are two sets, the number of elements in their intersection by number of elements in their union. That is what you mean by Jaccard coefficient, my friend. So of course here that is very different story, but what is asking, you are having a complete graph Kn on n vertices and note multiple spanning trees. You know, right, in Kn number of spanning trees are how many possible, sir? You are having number of spanning trees is equal to n power n minus 2. Right, n power n minus 2 is number of spanning trees. And you also know that number of Hamiltonian cycles in Kn, n minus 1 factorial by 2, and number of edge disjoint Hamiltonian cycles will be n minus 1 by 2. Edge disjoint means they do not have anything in common, and if you are having a Hamiltonian cycle, if you remove one edge, that is a spanning tree, right? See, that is the main idea in this problem, my dear friends. Okay, now he is saying that note that multiple spanning trees are possible. Each of the spanning tree is represented by set of, see, obviously spanning tree will have some set of edges. Now look at this, it is n greater than 4, he clearly given. N is greater than 4, he clearly given. Now which of the following gives the lowest possible Jaccard coefficient between any two spanning trees of Kn? See, what I do is, of course, he given for n greater than 4. I just take 5, n is equal to 5 I take. You all know K5. See, because this result for any n greater than 4, it should be satisfied. This result, whatever you get, it should be true for any n greater than 4, it should be satisfied. So you can take K5, if that is satisfied for K5, it should be satisfied for any Kn, because he is asking for any Kn. So that result is satisfied for any n greater than 4, it should be satisfied. So that is the idea, my dear friends. So what we do here is K5, I take it, this is K5. Okay, now here these are the edge disjoint Hamiltonian cycles. edge disjoint, but I don't need Hamiltonian cycle. I need a spanning tree. I just create a spanning tree. This spanning tree and one more spanning tree I want. I'll just take one more. Okay, redraw that. So one edge if I remove, this becomes a spanning tree. It is a spanning tree. Spanning tree. These two are spanning trees and they do not have any edge in common. Suppose if you call it as A, B, C, D, E, F, G, H, I, J. So this fellow contain A, B, C, D, E, and the other fellow contain, so I am just writing this spanning tree contain these edges, this spanning tree contain F, G, H, I, J. So these are the two sets we are having. Now Jaccard coefficient for this, if I take A intersection B by A union B. Of course, in this case, maximum they can have, union can have 10 elements, but intersection will be 0. So he's asking minimum Jaccard coefficient possible is 0. So that is answer. So for this answer is C multiple.
Hello everyone. So now in today's session we are going to discuss about the जनरल एप्टीट्यूड पार्ट ऑफ कंप्यूटर साइंस शिफ्ट 2. ठीक है, अब देखो यहाँ पर कुछ क्वेश्चन थे जनरल एप्टीट्यूड वाले, इसको थोड़ा सा हम लोग देख लेते हैं ध्यान से, उसके बाद फिर हम लोग आगे बढ़ेंगे. ठीक है, क्वेश्चन में क्या रहा क्या, पहला कि एक्सपेडाइट हो गया, हसल हो गया, हरी विच द फॉलोइंग, जो कि सिमिलर वर्ड्स हैं. अब इस वर्ड्स में तो ज़्यादा कुछ था नहीं. ठीक है, इन सारे वर्ड्स का क्या मतलब है कि इससे जो है एक्सेलरेट होना मतलब क्या होता है, स्पीड अप होना. रिटार्ड मतलब ब्रेक लगाना होता है. प्रोवाइड करना मतलब कुछ देना, और डिसेबल मतलब कि कुछ विच इज़ नॉट वर्किंग. ठीक है, तो इसमें बाय डिफ़ॉल्ट ऑप्शन नंबर ए आपका जो है बिल्कुल सही बैठ जाएगा, क्योंकि सारे के सारे वर्ड्स एक जैसे होने चाहिए, इसलिए आपके पास ये आंसर आपका एक्सेलरेट हो जाएगा. ठीक, नेक्स्ट में देखा जाए आपका, जस्ट अ सेकेंड, नेक्स्ट में देखा जाए आपका तो एक ब्लैक स्क्वायर है PQRS हैज़ बिन कट इनटू द टू पीसेस, वन पार्ट इज शोन इन द पैनल. अब देखो जरा, इस वाले क्वेश्चन में भी ज़्यादा डिफिकल्ट नहीं था. सबसे अच्छी चीज़ क्या है ना इस क्वेश्चन की, कि इस क्वेश्चन का डेटा बड़ा क्लीन एंड क्लीन गिवन था आपको. देखो फिट करना है ना, देखो ये वाला पार्ट जो है ना, इस वाले पार्ट को तो आप ध्यान ही मत दो. ये जो ऊपर वाला पार्ट है, देखो ये ऊपर वाला पार्ट इन दोनों का ठीक है, ये ऊपर वाला पार्ट ठीक है, ऊपर वाला पार्ट ठीक है, तो इसको नहीं ध्यान देना. देखो यहाँ क्या फिल होना चाहिए, एक छोटा बॉक्स फिल होना चाहिए. देखो ये वाला बॉक्स वाला एरिया कैंसिल हो गया. अब नीचे आने के बाद जो है ना, इधर राइट साइड में कोई जगह नहीं है, तो देखो ये भी कैंसिल हो गया और ये भी कैंसिल हो गया. ठीक है, अब इसके हिसाब से बस देखना था तुमको कि क्या इसमें सही तरीके से फिल होना चाहिए. ठीक है, और फिल होने के हिसाब से आई थिंक सबसे बेस्ट जो बैठ रहा है ये ऑप्शन नंबर ये बैठ रहा है, जो कि सी आपका बिल्कुल एक्यूरेट आंसर आ गया. ठीक है, ऑप्शन नंबर सी जो कि थर्ड है, ठीक है, वो बिल्कुल इसका एक्यूरेट आंसर बैठेगा. दे कैन बी क्लाउडी सनी द प्रोबेबिलिटी ऑफ, ये देखो ये भी बहुत इजी क्वेश्चन था. अगर सनी का क्लाउडी का 0.5 है, ठीक है, तो सनी का कितना होना चाहिए, वो भी 0.5 हो जाएगा, यही हमारा होगा. ठीक है, अगर सनी होने का जो अगर प्रोबेबिलिटी जो है 0.5 है, तो क्लाउडी होने का भी जो है 0.5 हो जाएगा, यही दोनों होगा ना. फॉर्मूलाज क्या बन जाएगा, अगर मैं इसका फॉर्मूला लिखना चाहूँ, आप मुझे सजेस्ट करो. देखो अगर इसका मैं फॉर्मूला लिखना चाहूँ तो प्रोबेबिलिटी के बेसिस पे भी कर सकते हो. ठीक है, जो या फिर आपके पास जो है, अगर हमें सपोज करो कि हमारे पास k क्लाउडी डेज है. ठीक है, तो अगर मेरे पास k क्लाउडी डेज है, ठीक है, ये कितना हो जाएगा. अब हमारे पास इसको हम लोग चाहें तो दो तरीके से कर सकते हैं. मैं आपको एक तरीका बता रहा हूँ, आप ये बताइएगा आपको ये वाला तरीका समझ में आया कि नहीं. ठीक है, जस्ट अ सेकेंड. ठीक है, आपके पास ये हो गया फॉर्मूला, तो आई थिंक आपको ये पता होगा ना. देखो जरा ये वाला फॉर्मूला, इससे इस टाइप का फॉर्मूला तो आप लोगों ने, मुझे नहीं लगता कि आप लोगों ने नहीं देखा होगा. ये फॉर्मूला तो आप लोग को पूरे अच्छे तरीके से याद होगा. ठीक है, ये वाला फॉर्मूला हो गया. अब इसी में वैल्यू रख दो, या तो 4 3 वैल्यू सीधे रख दोगे तो कितना हो जाएगा. देखो अब मैं इसी में जो है अपना 4 3 वैल्यू रख दूंगा, तो 4 3 फैक्टोरियल हो गया हमारे पास. तो अगर कितना हो जाएगा 4 फैक्टोरियल अपॉन 4 माइनस 3 फैक्टोरियल इंटू 3 फैक्टोरियल. ठीक है, एक तो ये इतना हो गया. वैल्यू कितनी हो जाएगी 4, यहाँ से 3 फैक्टोरियल कैंसिल हो जाएगा, केवल 4 बचेगा. वैल्यू में केवल क्या आ जाएगा हमारे पास 4 बचेगा. बाइनोमियल कोफिशिएंट के बेसिस पर हम लोगों ने एक वैल्यू निकाल ली. अब हमें क्या चाहिए, प्रोबेबिलिटी निकालनी है. ठीक है, तो 3 क्लाउडी डेज का प्रोबेबिलिटी कितना हो जाएगा, प्रोबेबिलिटी ऑफ 3 क्लाउडी डेज. ठीक है, अब 3 क्लाउडी डेज है तो इसमें कितना वैल्यू होना चाहिए, क्योंकि 0.5 क्लाउडी का है, 0.5 शनि का है, ठीक है। सो कितना हो जाएगा 4 इंटू 0.5 का क्यू हो गया इंटू 0.5। ये हम लोगों ने वहाँ पर भी किया था, जब हम लोगों ने एनालिसिस किया था भी ये क्वेश्चन हम लोगों ने किया था। तो इसकी वैल्यू हो जाएगी, क्योंकि मुझे आंसर भी इसका याद हो गया एक्चुअली, ऑप्शन नंबर ए इसका बिल्कुल करेक्ट आंसर हो जाएगा 1/4। ठीक है, नेक्स्ट द वैल्यू ऑफ अ स्टॉक। ये क्वेश्चन भी बहुत इजी था, ये क्वेश्चन भी हम लोगों ने किया था जब हमारे पास पेपर आया था ना, तब हम लोगों ने इस क्वेश्चन को ट्राई किया था। देखो कह रहा है क्या, द वैल्यू ऑफ अ स्टॉक ए एंड स्टॉक बी पर्टिकुलरली आर द 50 and 80 rupees respectively. The investor invests 100 in the stock, 80 in the stock B, sells the stock in the next day, and when the value of a stock A and 55 B is the 70, the profit made by the investor is equal to how much? देखो अब इस टाइप के क्वेश्चंस के लिए आप प्रॉफिट लॉस का पूरा कॉन्सेप्ट जानने की जरूरत नहीं है, बस थोड़ा बहुत जानने की जरूरत थी। पहले एक बात बताइए, अब मैं आपसे सीधे सीधे क्वेश्चन पूछ रहा हूँ, आप मुझे बताना, ठीक है। पहले आप ये पता कर सकते हो क्या, स्टॉक ए कितना परचेज किया गया था, ठीक है। अगर देखा जाए तो ए का स्टॉक जो हो गया वो 100/50 हो गया, तो ये तो 2 स्टॉक हो गया। और स्टॉक बी कितना हो गया हमारे पास 80/80 हो गया, ठीक है। तो इनका एक शेयर हो जाएगा, स्टॉक बी का आपके पास 80/80 हो गया, एक शेयर हो गया, ठीक है। तो अब हमारे पास बढ़ गए नाम, प्राइस बढ़े कितना है, ये 50 से 55 हो जाते हैं, ठीक है, और वो 70 हो जाता है। तो अब स्टॉक सेकंड वाले डे में कितना हो जाएगा, ए का स्टॉक कितना हो जा रहा है सेकंड डे में, ए का स्टॉक जो है 55 × 2 हो गया, ये तो 110 हो गया, ये तो हमारा ए का स्टॉक हो गया। और जो सेकंड वाले डे में आपका पहला स्टॉक आपने सेकंड डे का निकाल लिया, अब आपको दूसरा स्टॉक का भी निकालना था। डे 2 में दूसरा स्टॉक कितना हुआ, जो बी वाला हो गया वो कितना हो जाएगा 70 हो जा रहा है आपके पास, जो वैल्यू गिवन है हमारे पास 70 हो गई। डे 2 में दोनों की वैल्यू कितनी हो जा रही है 180 हो जा रही है क्या, ठीक है। तो डे 2 में दोनों की 80 भी हो रही है, डे 1 के टाइम पर भी 180 है, डे 2 के टाइम पर भी 180 है। तो नेट प्रॉफिट लॉस कितना हो जाएगा 180 - 180 इज इक्वल टू 0। ऑप्शन नंबर ए 0 इज अ एब्सोल्यूट करेक्ट आंसर। दोनों में देखो प्राइस बढ़ने से पहले या प्राइस बढ़ने के बाद, दोनों के केस में बिल्कुल सेम चीज है, तो कुछ खास डिफरेंस हुआ नहीं, ठीक है। चलिए अब आते हैं 5th। ओके जस्ट अ सेकेंड, इसको मुझे रिमूव करना पड़ेगा, ठीक है। अब क्वेश्चंस को इसको देखिए जरा, क्वेश्चन अगर ध्यान से पढ़िएगा आप लोग, तो इसमें कह रहा है क्या कि एक वही एनालॉजी के क्वेश्चंस दे रखे हैं, सॉरी स्टेटमेंट बेसिस पे क्वेश्चन दे रखे हैं, और उसी के इसको हमें देख के सही करना था, गलत करना था जो भी। तो जब रेन हो रहा है तो डांस कर रहे हैं, इसके बेसिस पर हमें निकालना था। देखो कुछ सिलॉक्स वाले पार्ट को भी इन लोगों ने काफ़ी यूज़ किया शिफ्ट 1 शिफ्ट 2 में, उसको इन लोगों ने इनइक्वलिटी के साथ मैच भी करा दिया, ठीक है। अब देखो जरा, पहला कह रहा है पीकॉक डांस ओनली व्हेन इट्स रेनिंग, देखो अगेन ये एक कंडीशनल लगा दिया, ठीक है। सो हमें पता करना था कि इसके बेसिस पर कौन नेसेसरली ट्रू है, ठीक है। अगर पीकॉक डांस ओनली व्हेन इट्स रेनिंग, ठीक है, तो यानी कि पीकॉक डांस कर रहे हैं जब हमारा रेन हो रहा है। अब ये थोड़ा सा जो है नॉट नेसेसरी वाला केस आ रहा है, क्योंकि ओनली का कंडीशन आ गया, तो पहला केस हमारा गलत। व्हेन पीकॉक डांस इट्स रेनिंग, देखो अब दूसरा स्टेटमेंट में क्या हो गया, अगेन नॉट नेसेसरी का केस आ गया, जब पीकॉक डांस है तो व्हेन लिखा हुआ है ना इट्स रेनिंग, व्हेन पीकॉक आर नॉट डांसिंग इट्स नॉट रेनिंग, ये एक बन सकता है, ठीक है। ये एक आइडिया लग सकता है कि हाँ ये एक प्रोबेबिलिटी बन सकती है, एक पॉसिबिलिटी है, एंड इसका भी गलत हो गया। फॉर दिस क्वेश्चन में ऑप्शन नंबर सी बिल्कुल हमारा सही जा रहा है कि व्हेन पीकॉक आर नॉट डांसिंग इट इज नॉट रेनिंग, ये 100% के इसमें आ ही जाएगा, ठीक है। सो सी बिल्कुल यहाँ पर एक्यूरेट आ गया। ये क्वेश्चन भी इजी था, वही आपका जो है जो वो होता है ना एनालॉगी था, बट थोड़ा सा इन लोगों ने कर दिया, वाटर को पी कर दिया, फूड को क्यू कर दिया। तो पी को अब आपस में इन दोनों को कनेक्ट करना है एक दूसरे से, ठीक है। अब अगर हमने आपस में एक दूसरे को कनेक्ट किया तो हमारा सॉल्यूशन आराम से आ जाएगा। अब वाटर पी, ठीक है, फूड क्यू, तो अब इसके बेसिस पर मुझे जो है इन दोनों आंसर को करेक्ट करना था कि क्या इसका आंसर सही होना चाहिए। अब वाटर से क्या होता है थर्स्ट हो गया, तो क्यू से हंगर हो गया, इसमें कॉम्बिनेशन करना था मीनिंगफुली एनालॉगी का। देखो वाटर ड्रिंक जो है ना पीने का है, तो इससे प्यास बुझाई जाती है, लेकिन यहाँ हंगर हो गया तो उल्टा हो जा रहा है, थर्स्ट नहीं, ये भी नहीं, सिर्फ ये बैठ रहा है। पानी प्यास लगती है तो थर्स्टी बोलते हैं, भूख लगती है तो हंगर बोलते हैं, सिर्फ ऑप्शन नंबर ए सही बैठ रहा है, बाकी और किसी भी ऑप्शन में प्रॉपर कॉम्बिनेशंस नहीं बैठ रहे हैं, ठीक है। सो थर्स्ट और हंगर पे बिल्कुल सही गया ये। इस वाले क्वेश्चन पे कई सारे स्टूडेंट्स के कई सारे डाउट्स हैं। कुछ लोग बच्चे बोल रहे हैं कि इसका 1 सही है, कुछ लोग बोल रहे हैं इसका सी सही है। मैं इसका सबसे लॉजिकल नॉर्मल लॉजिक बता रहा हूँ। देखो इसके 3-4 लॉजिक है, मैं इसका एक लॉजिक जो सबसे सिंपल तरीका हो रहा है ना, मैं उसको आपको वो समझा रहा हूँ। उसी सिंपल लॉजिक का मैं 2-3 तरीका भी बता देता हूँ कि क्या एग्जैक्टली ये लोग चाह रहे थे कि इसमें हो। अच्छा देखो ध्यान से जरा, पहले वाले में सारे के डॉट्स गिन लो। देखो इसमें कितने डॉट्स है, ब्लैक डॉट्स थे 6, 2 8 थे, इसमें 1 था, इसमें 6 था, कितने हुए 15 हो गए। अब इसको मुझे ना फर्स्ट रो में कितने हो गए 15 डॉट्स हो गए ब्लैक वाले, तो मैं सेकंड रो थर्ड रो में भी 15 चाहता हूँ। सेकंड रो में कितना है देखो तो जरा 3 है मेरे पास इसमें, प्लस 5 है इसमें, ठीक है 3 5 8 हो गया, 8 मतलब 7 डॉट होने चाहिए मेरे पास। तो देखो ये वाले ऑप्शन तो वैसे ही कैंसिल हो गए, या तो ये रहेगा या तो ये रहेगा। चलो ठीक है, थर्ड वाले में देखते हैं, यहाँ पर 4 + 9 हो गया, ठीक है। तो अब मुझे सिर्फ 2 की डॉट्स की जरूरत है, अब ये भी कैंसिल हो गया, सिर्फ ये बचा। सो ऑप्शन नंबर फर्स्ट ए इज अ करेक्ट आंसर। ये बिल्कुल लॉजिकल वे में नॉर्मल तरीके से सॉल्व किया हुआ क्वेश्चन है, ठीक है। इसमें कुछ ज़्यादा दिमाग लगाने की बिल्कुल भी ज़रूरत नहीं थी, ठीक है। आप चाहो तो इसमें अलग अलग तरीके से दिमाग लगा सकते हो, बी को भी सही कर सकते हो, लेकिन उतना ज़्यादा ज़रूरत था नहीं इस क्वेश्चन में कुछ। हाँ, इस वाले क्वेश्चन में काफ़ी सारे स्टूडेंट जो है परेशान हो रहे थे। मैं आपको एक तरीका बताता हूँ, आप ज़रा मुझे खुद बताना। अगर मैंने यहाँ से शुरू किया, ठीक है, ये देखो ऐसे गया मैं ऐसे, क्योंकि रिपीट नहीं होना चाहिए। देखो पहला फिगर तो बिल्कुल सही बन गया, ठीक है, तो ये तो बिल्कुल सही बन रहा है। दूसरा वाले में अगर मैं कोई भी केस लगाऊंगा ना, मान लो इसको भी लगा दूं, फिर वापस उसी जगह जाने के लिए मुझे रिपीट करना ही पड़ेगा। तो दूसरा कॉम्बिनेशन कोई ऐसा बन ही नहीं सकता है जिसमें कि कोई ऐसा ट्रिप बने जिसमें कि आपका दोनों जो है ओवरलैप ना करे, ठीक है। तो देखो एक ट्रिप 1 के लिए पॉसिबल है, लेकिन वो 2 के लिए नहीं पॉसिबल है, इसलिए ऑप्शन नंबर ए मेरा बिल्कुल एब्सोल्युटली करेक्ट है। नेक्स्ट, इसमें भी काफी सारे बच्चों को कंफ्यूजन था कि अगर पैनल गिवन है 4 रोज और 4 कॉलम का, तो अब इसमें रिप्रेजेंट करना था। देखो सबसे जो प्रोमिनेंट आंसर्स इसमें बन के आएंगे ना, देखो आपका सिंपल है। देखो ये वाला तो बिल्कुल कैंसिल हो जाएगा क्योंकि ये दोनों फिल ही नहीं हो रहे हैं, तो ये दोनों तो फिल नहीं हो रहे हैं, इन दोनों में फिलर होने के चांसेस है। अब कितने लोगों को लगता है ये भी सही है ये भी सही है, ठीक है, ये दोनों ऑप्शंस को सही मान लेंगे। बट अगेन सेम वही बात जो शिफ्ट 1 की बात हुई थी, जो ज्यादा सही लग रहा है ना, जिसकी प्रोबेबिलिटी जिसका जो है इंट्यूशन ज्यादा सही का है, उसको करना है आपको। ये वाला पार्ट थोड़ा ज्यादा लॉजिकली जो सही हो रहा है एज कंपेयर टू दिस, ठीक है। दैट्स वाई हम लोग इसको जो है लगा रहे हैं ऑप्शन नंबर बी के लिए। लॉजिकली बी भी सही है, सॉरी लॉजिकली सेकंड भी सही है, फोर्थ भी सही है, बट जो ज्यादा लॉजिकल करेक्ट होने के चांसेस दिख रहे हैं वो ऑप्शन नंबर सेकंड के लग रहे हैं, जो बी है हमारा, ठीक। अगेन फिर से अनबायस 6 टाइम्स रोल किया गया। ये भी हम लोगों ने क्वेश्चन जब हमारा वो हुआ था, आई थिंक एनालिसिस हुआ था, तो भी हम लोगों ने इस टाइप के क्वेश्चंस को किए थे। सिंपल क्वेश्चन है, ठीक है। कह रहा है क्या कि 1 2 3 4, अब इसमें जो है हर टाइम को जो ऐड करना था। अब जैसे 2 आ रहा है, ठीक है, फॉर एग्जाम्पल 2 आया, तो 2 को हम कैसे लिख सकते हैं? अगर हम मैक्सिमम जो डाइस होगा उसमें क्या क्या बन सकता है, देखो तो 1, 1 बनेगा। अब अगर हमारे पास 3 आता है तो क्या बन सकता है? अगर हमारे पास 3 तो 1, 2, 2, 1, 4 आएगा, तो क्या हो जाएगा 1 3, 3 1, ठीक है, 2 2, ठीक है। ये ऑप्शंस हो गए हमारे पास, ठीक। अब जैसे कि हमारे पास 4 है, ठीक है, तो ये बन जाएगा ऑप्शंस। लेकिन हमें बोल क्या रहा है इन लोगों ने कि 2 3 4 में सर्च करना है कि टॉप फेसेस ईच टाइम हो, तो 4 वाला ऑप्शंस हम लोग देखेंगे, सम के लिए देख रहे हैं ना, तो 4 वाला ऑप्शंस हम लोग का क्या करेंगे? डिस्कार्ड, ठीक है। अब इसको हम लोगों ने डिस्कार्ड कर दिया। अब 5 का ऑप्शन देख लीजिए, 5 वाले में क्या बनेगा आपके पास? 1 4 बन जाएगा, ठीक है, 4 1 बन जाएगा, 2 3 बन जाएगा, 3 2 बन जाएगा, तो यहाँ से भी आपके पास 4 ऑप्शन बन जाएंगे। फिर आपके पास 6 7 हो सकता है और 11 भी हो सकता है, ठीक है। तो 7 और 11 होने के लिए, 7 के लिए आप 1 6 ला सकते हो, 6 1 ला सकते हो, 2 5 ला सकते हो, 5 2 ला सकते हो, 4 3 ला सकते हो, 3 4 ला सकते हो। तो 6 ऑप्शंस यहाँ पर बन जाते हैं। और 11 का सिर्फ 2 ही बनेगा, या तो 5 6 आएगा या तो 6 5 आएगा, तो यहाँ से 2 बन गए। ऐड कर लीजिए तो 1 + 2 + 4, ठीक है, 3 3 4 7 7 और 6 6 12 1 13 2 15, ठीक है। तो टोटल कितने बन गए हमारे पास? 15 आ गए। नंबर ऑफ प्रोबेबिलिटी क्या थी? टोटल प्रोबेबिलिटी कितनी थी? 36, सो 15/36, ये इसका आंसर होना चाहिए। ऑप्शन नंबर सी इज द एक्यूरेट आंसर फॉर दिस वन। दैट्स बहुत ज़्यादा डीप में फिर से नहीं जाना था, इजी क्वेश्चन था, हल्का फुल्का इसको देख के बस इसको आंसर क्लियर करना था। 15/36 इसका करेक्ट आंसर आ गया। सो आई होप यू हैव अंडरस्टूड दिस क्वेश्चंस। स्टिल आप लोग का जो भी अगर है तो आप लोग अपने क्वेश्चंस को फिर से देखिए। कई सारे बच्चे मैसेज कर रहे हैं सर उनका आंसर गलत आ रहा है या फिर आंसर की गलत है। ये मास्टर आंसर की शीट है, हो सकता है आपके ऑप्शंस थोड़े ऊपर नीचे हुए, तो आप अपने ऑप्शंस को सही से मैच करके फिर ट्राई करिए। ओके, so that's all for today guys. Thank you so much for watching this lecture. Thank you.
Let's have a discussion on GATE 2026, the computer science solutions from C and DS. Then we'll go for TOC, then CD, or all the subjects we'll see in a sequence. The first question is, in C runtime environment, which one of the following is stored in heap? So this comes under even compiler, so it's, you can assume it's a compiler question too, or C programming question. If you want to store in heap, then how do you create the memory, or how do you create, or which variables allocate in the heap? Basically, when you create a memory using the dynamic memory functions like malloc, cloc, the memory will be created on the heap. So now if I talk about static variables declared inside a function, there definitely will be created in the data region, right? Because once they create before the execution of the program, they'll destroy just after the execution of the program. It will not be depending on is it local or global variable, because they are static variables. An array of integers declared inside a function, definitely if they are not static, will be created on the stack. So once you enter into the function, the array of integers will be allotted on the stack. A dynamically allocated array of integers created using malloc will be freed only with the free function, and it is not related to the stack, not related to the data region, it is related to the heap region. And that's what we are talking about here. You need heap allocation. A return address of a function which will be allotted on the stack, that's basically an activation record. So activation records will be pushed onto the stack when they are called. So answer is C. Now we have the three programs. The first program, you have the A as a global, A as a local, and now the question is like which one will give you an error during compilation, or no error basically. Now P1, only P1 will compile without any error. Let's check that, is that true statement? You need to pick the true statement. A is the global and A is the local, so there is no kind of a compilation error here. So only P1 will compile, that I don't know, but P1 definitely will have no compilation error. So it's okay, no compilation error, right? No compilation error. Let's see the P2. A, there are two declarations for A. This will give you the conflict for the compiler, which A need to be allotted in that scope. In the same scope, you cannot have the two variables with the same name, so this will throw error. Which error? Compiler error. The type of error is the two variables have the same name, conflict will happen. So P2 definitely will have an error. And P3, again, whether it is integer or float, the same name cannot be used in the same scope. Again, the same issue will happen with the P3, and here also will have a compilation error. So only P1 will compile without any error, right? So that's why option A is the correct one. Now we have the set of keys, that is 5, 28, 19, 15, 26, 33, 12, 17, 10. These are inserted into hash table using the hash function, that is h of k is equal to k mod 9. The collisions are resolved by chaining method. After all the keys are inserted, the length of the longest chain you need to find. So chain, you know, right, the each location, how many you have, mod 9 means 0 to 8, correct? So let's take the index 0, 1, 2, 3, 4, 5, 6, 7, 8. Now the 5 mod 9 is 5. So here sorry, 5 mod 9 is 5 only, so we'll insert here at 5, and 28 mod 9 is 8. So 28 will be inserted 1. Yeah, sorry. 28 mod 9 is a 1. So here it will be inserted. And just check 19 mod 9 is again 1. So now the chaining is important here. Next 15. The 15 is going to be 6. So 15 is here. 26 mod 9. 9 to the 18. So 2 plus 6 is 8. So that will be here. And 33 is 6 again. Now you'll have here 12. 12 mod 9. Just check every time when you have a confusion. That is a 3. So 12 is here. And 17 is 8. And 10, 10 mod 9 definitely 1. So now what is the maximum chain length? You will see here the 3, right? So it's cross check if this is also getting the 3. So check again 26 mod 9. Is it 8? Obviously, right? And 33 mod 9. 9 3s are 27. So you have 3. Oh, 33 mod 9 is how much? So this is one mistake that I did. That's why I'm cross checking why it's going. 17 is fine. That's not an issue. And 6 already you have a 15. So 15 was inserted here and 33 will insert here. It's okay. Just you need to apply the mod, as I'm not writing on the slide. So could be possible that I'm mapping to somebody else. So mod 9 you calculate and find the remainders. As per the remainder, you just do the chaining. So now the longest length that you have here is the 3. And this is the longest length that you have, which is equal to 3. The answer is 3. Now we have a very different question. Please read the question. If it is not a readable format, then please take the paper and read it. I'll read here. Now the question is, consider a binary search tree with n leaf nodes. Given any node V, the key present in the node is denoted by a value of V. Okay, every node V, we just represent that key in that node is represented as value of V. All the keys present in the given BST are distinct. So whatever the BST is given to you will have all distinct elements. So no confusion of the duplications. The keys belongs to the set are real numbers. The value that you put in the node is going to be a real number. Okay, you can put 2.3 or 2.301, something like that. And for a node V, let SUC of V means successor of V denote the node that is there in the in order successor. Like it's going to be in order successor if I represent successor of V. So if for this V, if I represent successor of V, then in the in order it's going to be the next element. And if a node V does not have an in order successor, you can represent as successor of V is null. Okay, as there are no duplicates, if the successor of V is not null, then value of V definitely less than value of the successor of V. If you look at the value of successor of V is going to be greater than the value of V, and if it is not null, if it is null, anyhow we will not compare. Corresponding to every leaf node. Now this is a data given to you. What is the value of V? What is the value of successor of V? What is the successor of V? What is V is given in the data. And now the question is going to start like this. Corresponding to every leaf node Li. So I'm deleting the existing one. Every leaf node Li. So what is leaf node? Basically, let me give you the one simple structure. It will connect easily. So let's have a tree. So we will call as this is L1, L2, L3, L4. So these are the leaf nodes in general, and that has a non-null successor. So who is successor of L1? If I ask who is the successor of L1, after this will be the node in the in order it happens as a successor, right? For L2, this is a successor. So I can have a name for it. just giving a name to understand. This is the successor of L1 and this is successor of L2, and for L3 this is a successor of L3. When you write in order, then this will appear as a next node in the in order successor, right? The L4 we don't have any successor node in this. So now we have the clear representation of for every node Li, if it is that has a non-null successor, a new key a new key Ki we are going to insert into the BST. So now if see L1 successor is this node, if it is a non-null, then definitely we are going to insert one number, that is Ki. So the Ki is going to be inserted into the BST. Now the question is, the K represent a list of all such new keys to be inserted into the BST. Which of the following statements are true? Now if I insert the after L1, the next the in between the two values, that L1 and the successor of L1, the value in between them if I insert, where will be inserted? Suppose if I pick here, the value must be less than this, but it should be greater than this because it should be in between these two, right? If this want to be successor of this one, L1, then the value of the Ki should be here. So where do you insert? You will insert that K, let's say 1, and here you will insert K2 and you will insert K3, and for this there is no successor, so you can't insert K4. So now the value inserted here. So this is the whole history of the data, and this data is very important. All the data is represented here. Now which of the following statements are true? Okay, first one, K cannot have any duplicates. Now the K represent the value that we are inserting. Suppose if I have a duplicates, then this value will never we should match with somebody else. If it matches, then this relation will fail basically. So the first statement is obviously true, as you don't have the duplicates. If you have the duplicates, then we may not have the insertion, as you know, the relation will fail to insert. The next one, K will have at least one element. Suppose there is no if I have, let's say, only one node here in my BST, then its successor will not find. Then how will you insert the Ki? So this is not guaranteed. And if given PST as having only one node or empty list, then you can't insert. After inserting all keys from K, then now you know, if it is my perfect binary tree, this is the maximum that I can insert, the 3 keys I can insert from my list. The height of the BST can increase at most by 1. If you see that, the hardly I will increase 1 level. So this statement is also true. And number of nodes in BST will double after inserting all keys from K. See, I have 7 nodes here. If I insert the keys, I will insert only 3, not double. So this number of nodes will not be double. So this statement is going to be false. As you see that this example will give you counter for the last option. So right answers will be A and C. Now we have the stack and queue, S and Q, stack as well as queue. Both of them are initially empty, have the capacity to store 10 elements. Now the size we have up to 10. The elements 1, 2, 3, 4, 5 arrive one by one in the same order, like 1, then 2, then 3, then 4, then 5. When an element arrives, it is assigned either to stack or to the queue. So you can push onto the stack or you can insert into the queue. Once all the 5 elements are stored, the output is generated in 2 steps. Okay. Now the first stack is emptied by popping all the elements, and then queue is emptied by deleting all the elements from the queue. We can call DQ. The output obtained from the by the following the process, like what will be the output you get, that is 4, 3, 1, 2, 5. The output we are expecting 4, 3, 1, 2, 5. To get this output, what should be the stack and the queue, the operations that let's read the remaining. Which of the following options are possible? Valid assignments of the elements. Now in the options, the notation XS denotes the element X was assigned to S, and YQ denotes the element Y was assigned to Q. So now 1, 2, 3, 4, 5, the which one is assigned to stack, which one is assigned to queue, that we need to mention here. First one, now to understand the stack, you need to look at in the reverse order, because stack we are going to pop first, all the element. And then this is the first process, right? Then we are DQ here. We delete all the elements. This is second. Now, first you need to look at in this reverse order that 4, 3, 1 should be here, or 4 or 3, it doesn't matter. Q, you should see the same order that you insert. So now in the stack, you are going to pop first. Now look at here, 4 I want to pop first, because stack I need to do first, right? If you look at 4 I want to pop first, then in this, the 4 should be inserted last. The 4 is inserted last, 4 is inserted last, 4 inserted last. No, this is wrong, because 5 is inserted last. Now, right, 5 is pushed last basically. So now here the 3 is pushed last. You'll get 3 first. So last two options are eliminated by looking at I want 4 first. So 4 should be popped first here. So that 4 will come first. Now these two are having the 4 was pushed last onto the stack. Now that's why when you look at here, the 1 is pushed, 3 is pushed, 4 is pushed. So then 1, 3, 4 will be on the stack, and Q, 2 and 5 will be there. 2 is inserted first and 5 next. Then while deleting also 2, you will delete first. Now 4, 3, 1, 2, 5 is exactly comes from the first option. So option A definitely true. Option B, check that you have the 3 and 4. First we'll see 1 inserted into the queue, 2 inserted into the queue, 5 inserted to the queue, and in between here 3 is pushed onto the stack, 4. So 3, 4 is here. So when you do pop first, 4, 3, 4, 3 comes first, then 1, 2, 5 in the same order comes. So B is also correct. But when you look at this C and D, we'll see C and D what happens when you do with the stack and queue. 1 you push down to the queue, then 2, then 3, and this is there on the queue, and 4 and 5 on the stack. Now when you pop the first stack, 5 comma 4 comes. From here the output comes 5, then 4, then 1, 2, 3. So this is a different output than this one. And similarly here 1, 2, 3 you are pushing onto the stack, and 4 and 5 you are inserting into the queue. Now when you pop this 3, 2, 1, from here the output comes 3, 2, 1, then 4, 5. So this output is different from this one definitely. So option A and B are correct. Now we have very simple program, like just go with the flow. You have a pointer A, B, C. A is having 5 and B is having 11, C is 20. Now PTR initially having the address of A, and then the star PTR, that means the content of A will be copied the C values 20, and then PTR that's updated to the C, so it will point to the address of C. And now A is equal star of ampersand B means A is equal to B, the B value will go to the A, and C is equal to star PTR. Now PTR is pointing to this, star PTR is 20, 20 minus 11 is 9, 9 is assigned to the C. C is equal star PTR minus A. Star PTR is 20, A is 11, so 20 minus 11 is 9, 9 will be assigned here. And then print C. So this is your output, 9 is going to print it because C is having 9 right now. So 9 is the right answer. And now this is one of the 3-star rated question. Could be very few people did this, because it will take 5 to 10 minutes to analyze if you don't have the knowledge of what happens between these 3 control statements, because the whole program is controlled by the 3 statements. One is if, the other one is else if, the other one is else. Okay, so there is the connection between these 3 logics. So let's see what is the question first. Now for this function you are giving the starting index and ending index, and the length is calculated how many elements are there from the start to end. And here when the length goes less than 1, that means the start and end crosses each other, or start is less than 0 or end is less than 0, you return 0 because nothing to do in it, right? Now when it is multiple of the starting to ending, if the length is multiple of 3, you will return the function by just incrementing. That means if there are 9 elements, then you will take the remaining 8 elements to do it. Okay, only index you are playing, not the actual element in the list. Now length mod 3 equal to 1, when it is the 1 modulo 3 your size is, then you will be adding the 1 to the return value, and you are calling the function by decreasing one element from the end. So end index will be decreased. Remember that end index will be decreased. And the another one is the whenever the remainder is 2, because only 3 remainders happens, either remainder 0, remainder 1, or remainder 2 when you divide with the 3. So when your remainder is 2, then you are increasing the starting index by 2. So basically total size will be decreased by 2. So that's the idea of the else part. Now you take any value, what happens, just check. I'll just take the simple example. Let's start with the some number randomly. We'll see what happens. Suppose if the first number that I just take the when I divide with the 3, I'll get a remainder 1. So that could be possible 4, or it could be possible 10, or it could be possible 16. So take any number, just check what happens. I'll take a 4. Right, that length should be 4. Length should be 4 means you can take 0 to 3, or you can take 1 to 4, 0 to 3 or 1 to 4, could be easy to do. 1 to, sorry, yeah, 4 elements you want it, right? So 0 to 3 or 1 to 4 is fine. So I'll take the starting index is 0 and the last index is 3. That's the start and end. Definitely when you do this, 3 minus 3 plus 1, 4, 4 minus 0 is definitely 4. So length I want a 4. So I got a length is 4. And now when you do it, the condition, the if condition will fail, then you come here, then now divide with the 3. The 4, when you divide with the 3, you will get a remainder 1. So when you get a remainder 1, the answer will be like 1 plus, you will call the function, the starting index is same, but ending index will become 2. Now you got what? Multiple of 3. So when you come to this, at any cost, it will convert to the multiple of 3. So this will, the second, the control statement will send the size to the multiple of 3. So now you remember this point. What happens once you got a multiple of 3? Now you will have a game. Like once you come here, it will send here. Once you come here, it will send here. Only this is going to happen. But anytime you come to this middle one, this will send the control back to this one when you repeat this recursive call. So now that 1 plus could happen only once. That is the first time if that given size or given length, or the length when you calculate, that is 1 modulo 4, that's remainder, so 1 modulo 3. When a remainder is 1, then the first time only it can do. If the first time remainder is 2 or 0, then 1 is also not going to happen. So it returns 0 only. So it will not return even 1. So understand what's happening. So this happens. Now what happens is, now 0 to 2, the size will be 3, multiple of 3, the remainder 0. So now immediately you will call a function, you don't do 1 plus. So what do you call? The func, that's a function of the start will be increased, that's 1 comma end is 2. Now this will be having the size, 2 minus 1 is 1 plus 1 is 2. So the size is going to be 2. Now this will call here. This function will call the func start plus 2. 1 plus 2 is 2, right? 1 plus 2 is 3. 3 comma 2. Now you see that when you find the length, what happens? 2 minus 3, that's going to be minus 1 plus 1, 0. So now it's going to be what? Length less than 1. So this will return 0. So when it returns 0, now what happens? 1 plus 0 is 1. This is the maximum value that you can get. So what is the logic behind it? The logic is very simple. The given number, that's first time when you calculate the length, if it is giving the remainder 1, the whole result will be 1. If the first itself remainder is 0 or 2, the return value is also 0. The logic behind it, if the length is multiple of 3, the next time, because you are doing the increment of the start, the size will be definitely, it goes to remainder 2 next time when you divide with the 3, right? If the first time, if the size, the length is giving remainder 2, the next time it will give you multiple of 3 because you are doing plus 2 to it. So understand what's going to happen here. So the logic behind it, it will be maximum 1 and if it is the first length is not giving remainder 1, then definitely it will return 0 if the first time it is not giving a 1. So the maximum possible value that can be returned from this function is 1, and in that two conditions I'm adding. If the first time when you are giving start and end, the length is not calculated as remainder 1, it will return 0 only. Okay, so anyhow the maximum value is 1 overall. Next I'm going to discuss the shift2 for the compiler. C runtime environment, which one of the following is stored in heap? So I think this question was discussed already, right, in C programming. So the answer is C. Now we'll have a lexical analyzer uses the following token definitions. Look at the letter and digit are the very basic. It's a symbol notation like A to Z, lowercase and uppercase, we represent letter, 0 to 9 we represent digit. Using the symbols notation, now we are defining tokens ID, number, WS. So what is the notation we have given? ID is defined as letter followed by letter or digit whole star, any sequence of letters and digits but starting with the letter. And number is nothing but any sequence of digits, but at least one digit should be there. WS could be, you know, the white space. You can have a blank or tab or new line, any sequence, but minimum one of them should be there. Okay, and for the string given, find the number of tokens excluding WS. So don't count the WS because they don't want to, even though they have given as a token. That will be produced by the lexical analyzer. Answer should be an integer. Let's try the first one. X followed by 1, and that is possible with the ID. So now this one, and white space is coming, so that will be covered by this. So this is going to be what? ID. And white space you can ignore, so I'm ignoring this WS because it's definitely WS, and we ignore them. And then we'll start with 2. Now digits, number, you can have any number of digits because the ID will not have a digits first. So 23 will be calculated or produced as number. So this is number because the characters or letters will not come after the digits. Then will be considered as your ID. This is another ID that you have, and the space is coming, so you can ignore it. So I'll just ignore it. And 78 is going to be a number, so I'll write number. I'll put a boxes, better not to write all this. I'll just put a boxes to identify. So this is one what ID, and this one is number, this one is ID, and you can delete the space WS. This is number and it is ID, and now this is a number 7 followed by Z. Don't include in the ID. The reason is the 7 is number, Z is ID, and space WS will ignore. Next ZZ5 will consider as ID, and 14 is number, A is ID, and 8 is a number, H is ID. Spaces anyhow we are ignoring, and all this sequence of characters will be considered as ID. So now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 tokens will be generated. And what are the tokens? You can also note down the tokens if you want it. The first one is the ID. This one is number, and this one is ID. This one is number, it is ID. This 7 is number, and Z is ID. This is number, ID. Number, A is ID, 8 is number. In future, the questions might happen like how many IDs are detected during this scanning. This ID. Total 13 tokens are there. Next one, this kind of question I was never expecting in GATE exam, but this year it has happened first time. Now for this you need to construct the whole a DFA, And that too, it is a LR0 table, so you can practice for LR0 table, but I don't recommend to practice LR1 table, which will be very complicated. LR0 is easy to compute closure and go to, so you can do that. So now the number of shift reduce conflicts that will occur in LR0 action table. Don't construct the table. In a DFA, you can find how many states are in conflict. That is same as how many states are having SR conflicts. That would be sufficient to find out, right? So number of SR conflicts that will occur is enough to identify. Only for SR you can look for the number of states are having SR conflict. Okay. Now S dash derives dot S and S derives. If you have any doubt, build a table and look for really do you have the same number of conflicts, same number of SR conflicts in table, same as that number of states are having SR conflicts. Cross check if you have any doubt. And because of A here, it's a capital C. We will write all the A items here. And dot epsilon, epsilon dot all are same, so you can have it. Now no capital B productions, no capital C productions here. This is the initial state. And do you have any SR conflict? Yes. This is the shift item, this is the reduced item. So one SR conflict we found here. So this is having SR conflict. I'll just mark it, later on we'll check. So this state is in problem. Now when you read S, what happens? This item will come here. That's all, no other, right? If you read A, S derives A dot CB. Because of this, after dot C is there, so C productions will include here. C derives dot C, capital C, and C derives dot. Now there is no other item included here. Now you can see, is there any SR conflict here? Yes. Which SR? Here this is reduced, this is shift. So this together produces one SR conflict here, and this state has SR conflict. Now when you read a small a here, I'll read this side. A derives A dot A. And now all the A productions you should keep here. A derives dot AA and A derives a dot. So now you can see you have SR conflict here. This is a shift item, this is a reduced item. This will also produce SR conflict in this state. Now here you read a C. Is this small c or capital C? It's a capital C, right? Dot should be moved. So when you read a C, the C dot B comes. Now B productions, is there any other capital C here? This is a capital C, right? This is a small c. And all the B productions will keep here. B derives dot B, B derives dot B. And here there is no conflict. Look at here, there is no reduced item here. And now small c we have to read. C derives C dot capital C. Now all the C productions you should include one more time. C derives dot. Don't write epsilon, is already reduced. Now you have a conflict. Which conflict? Reduced and shift. So this together will produce a conflict. This is not a shift item, not reduced item. So this item will not participate in a conflict. And from here, if you read A, what happens? A derives AA dot. And if you read A, you will come to the same state. So you can keep there. And now when you read a capital B, only one item comes, that is S derives ACB dot. When you read a B, then what happens here? B derives B dot B, and this B derives B also comes here, B dot. Because of this B, you need to write all the B productions back, dot BB, and B derives dot B. Correct? Now here definitely you have a reduced item, you have a shift item, so this will produce SR conflict. This will produce SR conflict. Now, that's it. Here C, when we read, you will complete the first one, reduced item. Now capital C is there, so that's the only one which you can read. And when you read a C, you will come back to the same state, and here nothing to read, and only this thing is left. Capital B, when you read here, so it will complete that item B dot. And here if you read a B, you will come to the same, so you can keep here. Now you can look at how many SR conflicts are there in the table, that you can look at by looking at how many states are having SR conflict. Don't look at here 2 SR conflicts, don't do that at all. Here 1 SR conflict, here 1, here 1, 3, 4, 5. So total 5 SR conflicts are there. Total 5 SR conflicts you can guarantee in table. So 5 SR conflicts. But RR conflicts you cannot count like this, because one state can produce more RR conflicts in LR0. But here in LR0, the single state can only produce 1 SR conflict, not like that RR conflicts. That's why SR conflicts you can build, you can identify without building a table too. But if they ask RR conflict, you should have more knowledge than this. Now, which one of the following options is a set of live variables at the exit point of each basic block? So now, if you look at this graph, exit point you need to identify here. Exit point, of course, this is a common point, and exit point, right? Exit point. So every basic block there is an exit point. From there, multiple controls might be going on. For this, especially for B1, the multiple controls are going, even though it is coming from here, but actually this is the same point for both of them. Okay. Now, options, let's see what are they given. Okay, they are asking about B1, B2, B3, B4. So you can compute directly by looking at here. So now for easy one, B4 is because it is not having any loop connection. So this exit point, directly I'll write an answer, I'll cross check, is there anybody matching with this? So here B4, the set of live variables is going to be pi. Is there anybody not having a pi? You can just delete B4 pi. That means it's obvious, so don't check for the B4. Now B3, B2, B1 that you need to compute. So B1, B2, B3. So let's compute one by one. Now I want to compute B2, then definitely from B4 you should compute the end set, then do that. So I'll give you another shortcut. By using live variable definition also you can do it very quickly. How I do it, you can check. So I want to compute here. Now from this point you check till the end of the program all the paths. Now every path goes to the last, right? So from here, now I'm reading the D, and before this, till this point there is no write into D. So D should be live here. And E I am reading, so no write into E before this. So D comma E definitely should be live here. So B2, the exit point, the D and E should be live. You can look at the option and you can easily cross check. The B2 is D comma E, B2 D comma E, B2 D comma E, B2. So you can eliminate one option from here, right? Now I'm going for B3 to do the same way without using algorithm. Now I'm going to point here, but I'll look at every path which goes to this end point. So I may come like this and I go there, or I may go this side. There are multiple paths I can reach to the future. So now I may check from this point, I may check this as my future also, because I can come this side, or I can go to this side, or I can go to this side, or I can go to this side. So all the paths you can try. Now let's try the one by one. Now here the live variable, so I'll just check first in the future. Now I'll check this B, I'm reading here and look at from here to here, is there any write in between? No. So I can say B is the live. And C, I'm reading here, is there any write from this point to this point in between? Is there any write? No write. So C is live. And I can come here. Yeah, A I'm reading here, but from this point to this point reading is there, but is there any write before? Yes. So A can't be live. So A I'm writing here, this can't be live. And F, I'm reading here, but from this point to this F, and we are reading and no write in between. So F should be live. And now I'll target this A. And when I'm reading this A, there is a write before. When I'm reading this C, now from this point to this point, E I have a read but no write before this. So E can be live. And I'll also try this D. D, if I'm reading from this point, then there is a write before it. So D can't be live here. D cannot be live here. And E already happened, so don't worry about it. So BCFE is a B3 exit point that you can cross check who is having that B3 exit point, BCFE. BCFE, oh, you have a lot of things. A is there, so already it is eliminated. CEF only there, so you eliminate it. Here ACF is there, eliminate it. So only A left, BCAEF, and obviously that is only left, so A should be blind answer without checking B1 also. But if you want, you can check the B, A, B, C, E, F will happen. How do you check them? Now this point, right? B1 exit. Now B1 exit, how many paths are there? This path is there and this path is there. Every path you have to check. Here I'm just writing from this point, I'll check this file. A is live, E is live, and D can't. A, E, I can take this too. When you go this side, because this edge is also, you can write here if you have any doubt. So A, you are reading here from this point to this point, there is no write, A already taken. F, you can take a live, and B, from this point to this point, if you go this side, the B is you are reading, no write before, and again C, right? And when you come back to this, then definitely you can look from here rather than this path. So A, E, F, B, C are going to be live at exit of B1. Okay. So if you use any algorithm like live variable analysis also, you can compute this. That's also a good method, but you can use the definition find quickly without using algorithm too. The answer is A. Now we'll see how shift to for the TOC. Now the question is, which one of the following statements is equivalent to the following assertion? Now they did not ask you which is decidable, which is undecidable. They have simple definition. They have asked, I'm giving you one statement, find the equivalent statement. Now people are thinking like decidability, then you are wrong. We should know definition of decidability. Now Turing machine M decides the language L subset of are equal to 0, 1 whole star. So this is the statement they have given to you. It's like assertion. And which of them are equal, which of the following is equivalent to this statement? See, if some Turing machine is deciding something, like let's say TM decides L, what is the meaning of this? The things which are in L should accept, things which are not in L should reject. That's the definition, right? That means the alternate Turing machine you should have. What is the alternate Turing machine definition? Then every valid string it will halt at final, every invalid string it will halt at non-final. Now that's the concept you have to check. Now TM halts on all inputs. You can't guarantee, you can't just give halt on all inputs, even though it's right, but not equivalent. Why? Because see, this statement will imply definitely this, because they said equivalent. Now this statement will not imply this. Even though Turing machine halt on all inputs, the problem is which inputs it will halt at final, which inputs it will halt at non-final. That L will not guarantee, it will give you some other language. So this statement will always guarantee it will halt on every input, but this statement will not tell you is it really doing L. So this side will fail, so equivalent will fail. Now the second one, Turing machine accepts all input strings in L. Now this is not a sigma star to say, it's a subset of sigma star, right? Those which are in L it should accept, those which are not in L it should reject. So this statement is completely, even one direction also fails, and rejects all inputs in the L complement. See, M should reject all inputs which are not in L, correct? So which are not in L, definitely here. So now if this statement is true, definitely it is going to hold this one. But this statement cannot guarantee it will accept all these strings in L. So this statement will fail to happen, this one. That's why equivalent will fail. So if they say this statement implies what, then definitely this is also correct. But they said equivalent word. So now last one, that's the definition. M should accept all inputs in L. M should reject all inputs which are not in L. Sigma star minus L means not in L. Now this is really equivalent to this statement. They are equivalent. So D is the right answer. Just they ask definition, what do you mean by M decides L? That means it should accept all the strings in L. It should not accept which are not in L. That means reject which are not in L. Which of the following grammars are ambiguous? Very easy question. Now, if you have a left and right recursion both, then grammar is ambiguous. And here right recursion, left recursion, so directly it will create ambiguous. These two options are ambiguous. Then just you need to check these two, are they ambiguous or not? This one, epsilon only one way, AB only one way, A square, B square only one way. So this is unambiguous. By looking at, you can easily answer it. And this one, epsilon one way, A one way, 2A one way. So A star strings will be generated in unambiguous fashion. Now here you see left and right recursion, definitely will have lot of strings who have more than one derivation here and here, correct? So B and C are going to be ambiguous. What is the reason? What is the reason? You have the left and right recursion, both we have left recursion as well as right recursion with the same non-terminal. Even though sometimes not having both will have ambiguity, but when you have it, clearly you will have ambiguity. Here also you have a left recursion and right recursion with the same non-terminal. So other two we checked it manually, but this two, by looking at left and right recursion, you have a left, you have a right. This is enough. You don't need this also. So same E is participating in left and right recursion. Your same S will participating in right as well as left. So we call it as ambiguity. So B and C is going to be the answer. Now, this is another interesting question in shift 2. Like you have a two finite automata, and now which of the following statements are true? Right now, based on the options, you conclude the statement. You need a true, right? Now, what is the first one? L of D1 is equal to L of D2. So I'll disprove them. They are not equal. Example, see here 000 you are accepting. What you are accepting? 000 is accepted here. Do you accept 000 here? No. 0, 1, 1, 100, no. So from initial state you can look at epsilon you are accepting in both, but next thing I'm showing it 000 is accepted here, 000 not accepted. So that's enough why the first statement is not true. Next one, L of D1 is a proper subset of L of D2. To fail it, I'll just show you one string. There is a string which is here, but that is not here. That means L of D1 is not a subset of L of D2. Counter example is I'll take a string which is in L of D1, but that will not be in L of D2. That statement will fail. Let me check that. So some string should be accepted here, but that string should not be accepted here. Example, 000 is accepted, and it is not accepted means that cannot be subset of this, right? So this is enough to prove that L of D1 is not a subset of L of D2. That 000 itself is enough. It will fail because 000 is here but not here. So it will prove that not a subset of L of D1, not a subset of L of D2. Now intersection is epsilon. Now I will show you something. It's going to prove in both of them, C and D. Now you see what are accepted here. Just I'm showing here epsilon accepted. Next, if anything is accepted, it's going to be 3 length only. But which 3 length? 000 here. I'll write all the 3 length. I'll check parallelly. Here epsilon accepted. 000 is not accepted here. Now 001 check here. It's not here, but you check here 001. 011 here. 001 001. It's there here. And it's not there here. And 010 check here. 01 not there here, and here 010 is there here. Where? This side 010 and 011 is here. And all the string starts with 0 for 3 length is over. Now 100. 100 is not here. Here is there. See 100 is accepting. 101 10 is not there this side, but here 101 is there here. 101. Next 110 is here. 110 and 111 this side 111. Now all the 3 length is accepted. When you are looking at here, the strings which are accepted here, are actually not matching. If you go for 6 length, definitely they should begin with this only because that's the 3 length cycles that you have here. Then those 3 lengths, these 3 lengths will never match because they see 011. If you are having here, no string starts with 011. So their intersection is going to be empty. Except epsilon. So only epsilon is accepted in both of them. So this is true. And now the question is, L of D1, epsilon is there, I'll write here L of D1 union L of D2 whole star. Now L of D1, you have epsilon and some 3 length strings as well as 6 lengths and so on, and L of D2 epsilon and some 3 length and 6 lengths also, but I'll just consider up to 3 length only because their question is consist of all strings in the world whose length is divisible by 3. Is it guaranteed or not? I'm just checking. Epsilon is there, and if you observe here the 000, 001, I'll write them 000, 001 plus 010 and 101, 010 and 011. Is that correct? Just check it. 010, 101, 101, 101. 101, and plus there are a lot of strings in L of D1 and plus. Now L of D2 will work epsilon. Now which strings we have here? 011, 100, 011, 100 plus 110, 111, 110, 111, and so many strings which are 6 length and whole star. Now if I want to guarantee, then every multiple of 3 length should be there. Is it there or not? 0 length already there, and whole star anyhow it's a 0 length is there, epsilon not required. And if you want any 3 length, any 6 length, any 9 length, any 12th length, definitely you can generate from here because all the 3 length are covered here, right? These 3 lengths are enough to guarantee that multiple of 3. Remaining are not required at all, correct? So that's why it's also correct. So C and D is going to be correct. Now which of the following constraints ensure that the language L is context free? And now A power I, B power J, C power K, D power L. Now you look at the conditions mentioned here. I plus K is equal J plus L. So I'm just writing here A power I, B power J, C power K, D power L. So what is the condition that we need to check here? I plus K. So this sum is equal to this sum. Now is it enough to be CFL? Because you can do the PDA like first the A's you check. If first A's are coming, push them, because definitely here greater than or equal 0 is there. So A's may come, may not come. If it comes, push it. If it is not coming, B's comes, push the B's. So you have 2 options now. A's may come, B's may come. If A's comes, push it. B's comes directly from the initial state, push it. But you don't know which one will come. So you have 2 choices now. I'm just assuming that A's comes, push it. Right? There's a one path, you go for A's, other path you go for the B's, because both inputs are different, so deterministically you can do. Now suppose A's comes, you push it. Now B's, IJ is the opposite side, so you have to compare. Now when you are checking with B and A, it could be equal, or it could be B's could be more, or B's could be less than A's. Then all the 3 situations you have to consider. What happens if B's equal to A? Then C comma Z naught will happen. Or string will not, C's and D's may not be coming. That's okay. Deterministically you can do it. If B is more than A's, then what will happen? B comma Z naught arises early. And if that does, then push the remaining B's and do the similar job with the C and D. Okay. If B's are less than A's, then B's can't pop all the A's. Then C will come or D will come. If C comes, C comma A. Check K and I. K and I both are same side. If the C's comes, you have to push when the A's are already on the stack, because C and A you have to combine together. So C comes, push, and then for the D's, D should pop the C's, D should pop all the A's. That's how you do deterministical, but it takes lot of comparisons. Definitely it is a CFL, but not that easy to construct. Even it is deterministical CFL. Okay, and I is equal to K, J is equal to L. I is equal to K, J is equal to L. That's what I'm talking about, right? The I and K you can compare, J and L you can compare. So now we'll see that is it possible or not. You can do the sum, but this is not a sum. What is this? A power I, B power J, C power K, D power L. Now you push A's because you need you need to compare with the C's in the future. B you need to push because you need to compare J with L in the future. When the C comes, you are not looking for the B, you are looking for the A, then you will lose the B if you do that. So if you lose the B, D you can't compare with the B. So this is not possible with the stack. So stack we cannot use to understand this logic. So it's not a CFL. The another one, I is equal to L, J is equal to K. You can easily compare A with the D, B with the C, push A, push B. For the C, you pop the B's, for the D, you pop the A, because connection between A and D and B and C, this is CFL. What is the connection you have? A power I, B power J, C power K, D power L. I, L you need to compare, J, K, that is B and C you have to compare. So push A, push B, and for the C pop the B, for D pop the A, because they should be equal. So there's the only comparison you can do. And I plus J is equal to K plus L, very easy. See, A power I, B power J, C power K, D power L. How do you do? Here push X only. Same symbol you can push. For this also push X, because you need to do the sum, right? So push X's only for the both. For this two, one after that. First pop the X, and as soon as complete the C's, then pop the X's for the D's. Okay. Overall, at the end, there is no X left on the stack. That's what this happens. So what is the answer? A, C, G. The more tricky part is the A is going to be taking a lot of time to design. Even it could take even 20 minutes to design the whole one machine, or could be 15 minutes. Okay. Thank you.
Hello my dear student, we are going to discuss the solution of COA shift 2. In this we will discuss each and every question and whatever the concept working behind that question completely. Okay, so first of all, what is mentioned in question number 18, in non-vector interrupt mechanism, it is usually take more time to start the ISR when compared to vector interrupt. Yes, it is true. S1 is true. Why S1 is true? Because in vector interrupt, in my dear student, vector interrupt, already ISR address we know, but in non-vector, firstly we don't have ISR interrupt subroutine address, so it takes more time compare to vector interrupt, my dear student. It takes more time compared to vector interrupt. So S1 is true. In daisy chaining interrupt mechanism, CPU pool the interrupt, the input device individually to determine the source of interrupt. No beta, that is directly wrong, because in daisy chaining, you know daisy chain interrupt mechanism, in daisy chaining don't use the pooling, not use pooling. Getting my point? So what we can say, S1 is true and S2 is false. Okay, so what we can say, C is the correct answer for this question. What bacha? C is the correct answer for this question, bacho. Okay. The next question 34, it is a NET. What is mentioned here? It is asking in a 32-bit IEEE 75 for single precision, the number 0x in hexadecimal C27100 is equivalent to, in which? So 0x C27100 27 C271. ओके, देखिए बच्चों, C111 C12 है 210010 7011 and 10001 and rest 0000000000000000. Okay, what is the value of E? E is 132, S is 1 and Mantissa is 1110001000000. So what is the value formula? You know already, minus 1 की power S 1 dot Mantissa into 2 की power capital E minus by S. By S is 127 minus 1 की power 1 dot 11100001000 into 2 की power 132 minus 127. This is negative 1.1 2 की power plus 5. Okay, that means we have to shift 5 bit. Okay, so 1 1 1 3 4 5 0 1 0 0 0 0 0 into 2 की power 0. This is negative. So what is the value? Like 1 2 4 8 16 and 32. Okay, so 48 52 60 minus 60.25 minus 60.25. So what we can say here, the correct answer for this question is minus 60.25 is the correct answer. Hope so you get it. Thank you everyone. And the next question, consider a processor which having a 16 general purpose register is 16 and 2 byte instruction format. Okay, so we can say number of register is 16, so we can say a register address field is 4 bit and instruction size 2 byte means 16 bit. 2 byte means 16 bit, and we have a variable size of code are permitted. We have a M type, R type and C type. Okay, great. We have a M type of opcode and instruction format, R type and C type. Okay, this is the 16 bit, this is also 16 bit, and this is also 16 bit. Now what is mentioned? M type, my dear student. M type contain 2 register operand and 6 bit immediate operand. Opcode, 2 register and 6 bit immediate. Okay, and what happened? R type 3 register operand. R type 3 register operand, C type register and 6 bit offset. 6 bit offset and register. Okay, so here what we can do, this is 4 bit, 4 bit, 4 bit, and here 4 bit, 4 bit. So what is the size of opcode here? 10 14, 2 bit opcode here, 4 bit opcode here and 6 bit opcode here. So which one is the primitive? And you start from the lowest bit in opcode wala. So which one is the primitive? M type. Okay, now what is mentioned? Given 2 M type, given M type, 2 opcode and R type 7 opcode, and this one is asking. Okay, so it's very easy. There are other method also, but I always say ki follow this one because you will do very less mistake. Right? So first of all, total number of operation is how much? 2 raised to power 2. 4 given is how much? 2. Free is how much available? 4 minus 2, 2. So here total operation, free opcode multiply by 2 की power increment bit in opcode, and given is available 7, given R type 7, then how much free? 8 minus 7, 1. Now here total operation in C type free opcode into 2 की power increment bit in opcode. 4 is the correct answer for this question. So you can say, my dear student, here 4 means B is the correct answer for this question. B is the correct answer for this question. Hope so you get it. Thank you everyone. Next. In this question, what is mentioned, my dear student? Consider a system with 4 KB direct map cache. Cache memory 4 KB and main memory 16 MB. Block size 16 byte. Okay. So direct map cache, how you divide? Tag, line offset and word offset. This is 16 KB means 2 raised to power 24 byte. Mean to say your physical address is 24 bit. Block size 16 byte means 2 raised to power 4 byte. Means word offset will be 4 bit. Number of lines, how to calculate? Cache memory size upon block size. 2 raised to power 8 lines. So line offset will be 8 bit. Okay. And tag is how much? $12 bit. Okay. Total number of lines is how much? 2 raised to power 8. 256 lines we have. We have 256 lines total. Okay. Now we have some address given. What is the address given? P is given 0x845 B32. 845 B32 and Q 845 B26 R 845 B36 and S 846 B32. 846 B32. Okay. So what we do now? First of all, we divide it. Okay, 12 bit. 12 bit for tag and 8 bit for word offset. In this manner, we divide, then we check. This is tag 12 bit, line offset 8 bit, and word offset 4 bit. Okay. So what we can write? This is B3, B2, B3, B3, and tag 845, 845, 845, 846, 2662. Okay. And we have a lines. In which total how many lines we have? 0 to 2 raised to power 8 minus 1. Mean to say 0 to 255. But we have a line number B2 and B3 in hexadecimal also. B2 and B3. Okay. Now what I am doing? First iteration. What is the question? Assume that initial cache is empty. है ना? The sequence is PQRS, PQRS, PQRS in this manner. So what happened in a first iteration? P B3 cache is empty, miss. So at B3 we bring P. Next Q on B2, that is miss initially, here Q. Next R. Now you can see B3 line number same and tag is also same, means same main memory block. So P and R here. Next S, that is also mapped to the B3 but tag is different. That means it is a different main memory block. That means it is a different main memory block. So it is miss. So we replace this and bring S. Okay. Now next iteration, second iteration. P, because P is not here, miss. So we bring P here. Next Q. Q is already available, so Q is hit. Now R, because when P is here, then again you can say R is here because same main memory block. Now S, there is again miss. So you bring this S and remove P and R. Same thing happening in third iteration. Same thing in the third iteration. Same thing happening. Okay. Now read the options. Every access to result P result in a cache miss. Mean to say whenever you access a P, there is a miss. Yes sir, it is true. Every access to the R, because P and R, what happened na? P and R map to same cache line and same main memory block, because you can see tag bit is also same. Okay, so every R is a hit. Next, every access to Q result is a cache miss. Every axis, no, this is false. False. Only first time Q miss and remaining all axes it's hit. All axis of Q hit. Are you getting my point? Remaining all axes of Q are hit. Next, except the first axis of S, subsequent is a cache hit. No, because S every time miss. S every time miss. So here this is also wrong answer. So what we can say, my dear student, we can say here A and B is the correct answer for this question. A and B is the correct answer for this question. Hope so you get it. Thank you everyone. In this question, what is mentioned here, this is a OS question that is taken by Khalil sir. This is my question. Sorry. Question number 56. What happened? Consider a system in which 1 MB physical memory is given, 1 MB, and word length of 1 byte. Okay, the system use direct map cache and block number starting from 0. The physical address. What is the physical address is given? 0x in hexadecimal A2C28 is mapped to block number, line number 176 in decimal. Okay, the maximum possible size of cache. So first of all we will write A2C8. A means what? 10. 2, C 12, 2, 8. Okay. Now we have to find what is the maximum cache size. But it is one thing is mentioned कि this address mapped to the line number 176. Okay. So we can write the 176 value. What is the 176? 132 plus कितना होगा 132 plus 32 कितना हुआ आपका 160 128 plus 32 160 then 16 this is the line number. Are you getting my point? Clear है यहाँ तक? This is the line number. What 1011 and 4 times 0. Very good. This is the line number. Clear? So what we can say, this is the word offset and this is the line number, but it is asking maximum possible size. For a maximum possible size we can take here now till here now. Maximum possible size we can append these 30 also now, because it not impact this value, it not impact this value. You are getting 176 है ना. So what happened here, you are getting 3 bit. So this is the word offset and this is the line, and complete is cache index. How many bit? 17 bit. कितना बच्चों? 17 bit. So what is the cache size? Maximum cache size is how much? 2 raised to power 17 byte. That is 128 kilobyte, my dear student. 128 kilobyte. So it is asking ki you given the number in a integer. So what we can say, 128 kilobyte hai. So it is already mentioned in KB. So you can write 128 is the correct answer for this question. 128 is the correct answer. Hope so you get it. In this question, what is mentioned? A non-pipeline execution unit operate at 1.6 gigahertz clock and take 5 clock cycle. Okay. So first of all, we are talking about the non-pipelining. What happened? Cycle time 1.6 gigahertz. So cycle time is 1 upon 1.6 nanosecond, 1 upon 1.6 nanosecond and 5 CPI. 5 clock cycle it will take. 5 clock cycle. So what is the execution time in non-pipelining? 5 clock cycle, and 1 cycle time is 1 upon 1.6 nanosecond. So what is the execution time in non-pipelining? We can calculate 5 divided by 1.6, 3.125 nanosecond. Okay, 3.125 nanosecond, my dear student. Okay, now what is mentioned? To improve the performance, the system was pipeline. बेटा ऐसे टाइप के क्वेश्चन पता नहीं कितने कराए महा रिवीजन में, यूट्यूब पे है ना, फ्री ऑफ कॉस्ट कराए है ना, क्रैश कोर्स में कराए, मिशन 100 में, अग्नि परीक्षा में, फाउंडेशन बैचेज में, खूब जगह हर टाइप हर जब बार कराए इसको. टू इम्प्रूव द परफॉर्मेंस द सिस्टम वाज पाइपलाइन. एवरेज सीपीआई बिकम 1 इंस्ट्रक्शन पर साइकिल. नाउ सीपीआई 1 but the clock rate 1.2 gigahertz. Now what happened? It is mentioned in a pipelining, cycle time is reduced 1 upon 1.2 nanosecond. It will become 1 upon 1.2 nanosecond. Are you getting the point? And 30% instruction having 2 stall cycle. I told already कि out of 100 and 30% you are facing 2 stalls. Okay. So what is the number of stall per instruction? 30% में 2, because it becomes 0. Are you getting my point? 30% में 2, 70% में 0. Clear? So what is the average instruction execution timing? Yeah, you can say execution timing in pipeline 1 plus number of stalls per instruction into cycle time 1 plus 0.6 into 1.2 1.6 into 1.2. So what we are getting 1.6 divided by 1.2, you are getting execution time in pipeline, that is 1.33 nanosecond. 1.33 nanosecond. And what is the asking? It is asking what? Speed up factor over pipeline, and pipeline design over non-pipelining. So what is the speed up factor? It is asking ki pipeline over non-pipelining. So you can say execution time in non-pipelining upon execution time in pipelining, because you know performance is inversely proportional to the execution time. Okay, so what we can say, 3.125 divided by 1.33. So you are getting 2.3496. So we can say 2.34 to 2.35, and these range are given 2.34 to 2.35. Yeah, you can say 2.3 to 2.4, you can take 2.3 to 2.4. All are acceptable. Clear? So here we can write 2.34 is the correct answer, है ना? But you can write 2.3 or 2.4 also, and this was range that was given. Okay, so this is the solutions of COA shift 2. Hope so you enjoy it, and उम्मीद करता हूं सबने ये सारे क्वेश्चन सही किए होंगे, बिकॉज ऐसा कुछ नया क्वेश्चन नहीं था, एक आधा ट्रिकी क्वेश्चन था, लेकिन उस टाइप के क्वेश्चन भी अपन ने बहुत किए हैं. सो वंस अगेन, गॉड ब्लेस, थैंक यू एवरीवन. Hello my dear student, we are going to discuss the solution of DBMS shift 2. In this we will discuss each and every question, and whatever the concept working behind that question discuss completely. Okay, so question number 15, it is MCQ. What is mentioned? In the context of DBMS, consider the two set T and S given below कि logical schema, physical and external schema, है ना, view, file organization, indexing and relation. So my dear student, it is a very simple question, and आप इसको बीटेक की नॉलेज के भी पे भी कर सकते थे. You know logical schema means what? Relation. Logical schema means what? Relation. That means first belongs to N, and external schema means view, third belongs to L, and physical schema means, my dear student, file organization and indexing, second belongs to M. Okay, so first N, M, L. N, M, L, you can see this one here. C is the correct answer for this question. C is the correct answer for this question, my dear student. कि logical schema you can say relation, physical, file organization and indexing, how the data physically stored, organized, and external means view level, view. Clear bachcha? So easily you can say first N, second M, and third L. Hope so you get it. In this question number 20, consider the concurrent execution of two transactions. Very, very, very simple. Concurrent execution of two transactions T1 and T2 in DBMS, both of which access a data item A. For these two transactions, do not conflict on A. Which of the following statement must be true? आपको पता है what is the conflict operation? What is the conflict operation, my dear student? When Ti and Tj working on same data item, then if read A, write A. Are you getting the point? Or write then read, or write and write. These three are conflict operation. And which one is non-conflict? Only both are performing read. both are performing read, then it is what? Non-conflicting. Okay, or different data item. Then it is allowed. Are you getting my point? Different data item like read A, write B, then no problem. But here it is mentioned ki same data item A. So what happened? Both will perform on read A. So my dear student, what is the correct answer for this question? Here we can say A is the correct answer for this question. Hope so you get it. Thank you everyone. Next, in this question, what is mentioned in the context of schema normalization in relational DBMS, what is mentioned? The FD is given and the set of all FDs which is implied by F is called closure of F. Okay, correct. To compute the closure of F, Armstrong axioms can be used. Yeah, applied. Consider X, Y, Z is a set of attributes in a relational schema and three rules. You know three rules: R, A, and T. Reflexive, augmentation, and transitivity. These are the three major rules, and additional rules can be derived from these three rules. Additional rules like union, decomposition, and pseudo transitivity. If you remember, what are the additional rules? Union, decomposition, and pseudo transitivity. And what is saying ki the additional rule of union is defined as follow: X tends to Y and X tends to Z, then X tends to YZ. It can be proved that additional rule of union is also implied by three rules of Armstrong axioms. List below the four combination of these three rules. Which one of the combination both necessary and sufficient of the proof? Reflexive, augmentation, and transitivity. Reflexivity and augmentation. Transitivity and augmentation and transitivity. Okay, what is mentioned, my dear student? What is mentioned? X tends to Y and X tends to Z, then X tends to YZ. Are you getting my point? ये कौन से रूल से अप्लाई कर सकते हो आप? तो can we write in this manner? X tends to Y है. Can we write X Y? Are you getting my point? X Y tends to, या आप इसको अलग तरीके से भी सीख सकते हो. ये आपको गिवन है, ठीक है? This is the union, and which one we have? Reflexive, augmentation, and transitivity. Reflexive, augmentation, and transitivity. Transitive. Are you getting the point? Reflexive, augmentation, and transitivity. Clear? So X tends to Y given है, तो can we write in both side X augmentation rule and X tends to Z given है, can we write both side Y? Are you getting my point? Can we write both side Y? Applying the augmentation rule. Applying the augmentation rule. Are you getting my point? Clear है? क्या? देखिए, first of all you have to understand what are the additional rules. Additional rules are union, decomposition, and pseudo transitivity. But it is asking about only union. कि यूनियन किस रूल से आ जाएगा? आपको x से y गिवन है, x से z गिवन है. तो अगर मैं आर्गुमेंटेशन रूल लगा देता हूं, आर्गुमेंटेशन रूल क्या बोलता है कि अगर x से y है तो मैं x z से y z कर सकता हूं, यानी मैं कुछ ऐड कर सकता हूं. तो मैंने क्या किया, इधर x से y गिवन था, मैंने x और लगा दिया. क्लियर? x से z गिवन था, मैंने y लगा दिया. यहां तक समझ में आ गया? अब आप इधर देखिए, अगर मैं बात करूं अब ट्रांजिटिविटी की, अगर मेरे पास ऐसा केस बन रहा है x से x y से z, तो कैन आई राइट x से yz या x से yz? आर यू गेटिंग माय पॉइंट? तो कौन सा रूल लगा इधर? ट्रांजिटिविटी. यू नो ट्रांजिटिव रूल, x से y एंड y से z, देन x से z. गेटिंग माय पॉइंट? तो x से y, y से z, तो यू कैन सी x से y, y से z, इसको x मान लीजिए, इसको y, इसको z, तो आपका सिंपल सा ये प्रूव हो गया। कौन से रूल से? अगमेंटेशन एंड ट्रांजिटिविटी, अगमेंटेशन एंड ट्रांजिटिविटी। क्लियर? नेक्स्ट क्वेश्चन, डायरेक्ट स्ट्रेट फॉरवर्ड क्वेश्चन है। In an index in DBMS said to be dense if index entry appear for every search key value in the index file, otherwise it is called sparse. Consider the two following statement. Hash index must be dense. Yes, absolutely correct. And B plus tree can be sparse index. Yes, B plus tree also can be sparse index, my dear student. So what we can say directly, you can say it is a S1 and S2 both statement are true. So A is the correct answer for this question. So this is the solution of DBMS GATE 2026 Shift 2. Hope so you enjoy it.
हेलो एवरीवन, वेलकम बैक टू गिग्स फॉर गिग्स। सो माय डियर फ्रेंड्स, आज हम लोग बात करेंगे गेट पेपर शिफ्ट 2 के बारे में। तो कंपैरेटिवली, जैसा कि मैंने आपको पहले भी बोला था, शिफ्ट 1 के पेपर में कंपैरेटिवली जो शिफ्ट 2 का पेपर था वो थोड़ा सा इजी था शिफ्ट 1 के कंपैरिजन में, राइट। बट शिफ्ट 2 में जो सीएन का पेपर था वो थोड़ा सा कॉम्प्लिकेटेड था। कुछ क्वेश्चन बहुत स्ट्रेट फॉरवर्ड है जो आप देखते के साथ ही आंसर कर सकते हैं, कुछ क्वेश्चन जो है वो थोड़ा सा ट्रिकी है, कुछ क्वेश्चन कंफ्यूजिंग भी है। बहुत सारे स्टूडेंट ने उन सारे कंफ्यूजिंग क्वेश्चन का भी सही आंसर किया है, ठीक है ना। बट आज हम लोग उसका डिटेल में सॉल्यूशन डिस्कस करने वाले हैं। तो चलिए बात करते हैं कंप्यूटर नेटवर्क शिफ्ट 2 की। ओके फाइन, सो दिस इज द फर्स्ट क्वेश्चन ओवर योर स्क्रीन। आई होप इट इज विजिबल टू ऑल ऑफ यू, राइट। सो सबसे पहले इस क्वेश्चन को देखते हैं। ये एक ऐसा क्वेश्चन है जो थोड़ा सा कंफ्यूजिंग था, जो आपके गेट के पेपर में पूछा गया था, ठीक है ना। और ये स्टिल कंफ्यूजिंग है। बहुत सारे लोग अलग अलग तर्क दे रहे हैं इस क्वेश्चन को सॉल्व करते हुए। हमने इस क्वेश्चन को अपने मेमोरी बेस क्वेश्चन जब हमें रिसीव हुआ था तभी भी हम लोगों ने इस क्वेश्चन को सॉल्व किया था, राइट। और सॉल्यूशन मोर एंड लेस वही एक्यूरेट है, ठीक है। बट स्टिल वी विल ट्राई टू अगेन सॉल्व इट अगेन, राइट, एंड वी विल ट्राई टू फाइंड व्हाट कुड बी द पॉसिबल आंसर, या क्या हम कर सकते हैं इस क्वेश्चन को लेकर के। तो चलिए, क्वेश्चन में क्या दिया हुआ है, कंसीडर फाइल साइज 4 मिलियंस बाइट being transferred between two hosts connected via a path consisting of 3 consecutive link of the bandwidth 2 Mbps, 500 kbps and 1 Mbps। तो चलिए देखते हैं। तो ये हमारा सोर्स नोड है, ठीक है ना, सोर्स नोड है। इंटरमीडिएट पे हमारे पास 2 राउटर्स होंगे, ये हमारा डेस्टिनेशन नोड है, राइट राइट। हम लोग सारे पॉसिबिलिटी को कंसीडर करने की कोशिश करेंगे यहाँ पर। और ये इंटरमीडिएट पे हमारे पास 2 अलग अलग राउटर्स हैं, फाइन फाइन। सो लेट्स सी। अब लोग इसके बारे में अलग अलग तर्क भी दे रहे हैं, बट हम लोग हर एक पॉसिबिलिटी को आइडेंटिफाई करने की कोशिश करेंगे। दिस इज द राउटर R1, दिस इज द राउटर R2, दिस इज द सोर्स एंड दिस इज डेस्टिनेशन, ठीक है। इस क्वेश्चन को देखिए, कभी कभी हमें ऐसा लगता है कि गेट अगर पूछ रहा है तो गलती नहीं कर सकता है, राइट। ये हमारे दिमाग में एक इमेज होता है, लेकिन ऐसा नहीं है। गेट बहुत बार ऐसे क्वेश्चन पूछा है जो क्वेश्चन इनकरेक्ट है, बाद में किसी स्टूडेंट ने क्लेम किया तो उसने उसको रेक्टिफाई भी किया है। और इस क्वेश्चन को स्पेशली देखने के लिए मैंने बहुत सारे बुक को एक्सप्लोर किया, और एक्सप्लोर करने के बाद क्या फाइनली आया है उन सारी चीजों के बारे में बात करेंगे। तो हमारे पास 3 लिंक्स हैं। दिस इज द लिंक L1, L2 एंड दिस इज द लिंक L3। इस लिंक पे जो हमारा बैंडविड्थ है वो हमें दिया हुआ है 2 Mbps, ये बिट पर सेकंड है। इस लिंक पे हमारा जो बैंडविड्थ है वो दिया हुआ है 500 kbps, राइट। और इस पर्टिकुलर लिंक पे जो हमारा बैंडविड्थ है इट इज गिवन एज 1 Mbps। एम आई करेक्ट? सो लेट्स गो बैक एंड verify it's once again. Okay, 2 Mbps, 500 kbps, 1 Mbps respectively. All the processing delay and the propagation delays are negligible. Obviously, the process will get propagated as well as once the packet will receive by the router will process it after storing the packet and then it will be forwarded, ठीक है ना। तो ये स्टोर फॉरवर्ड टेक्निक का बेसिक सा क्वेश्चन है, ठीक है। Assume that there is no other background traffic over the paths and no other additional overhead to transfer the file. Which one of the following is the total time? इस बात पे फोकस करते हैं। टोटल टाइम किस में कंप्यूट करना है हमें? सेकंड में। टू ट्रांसफर द फाइल, 1 m का मतलब, चूंकि ये बैंडविड्थ है तो बैंडविड्थ में 1 m का मतलब होता है 10 टू द पावर 6, 1 k का मतलब होता है 10 टू द पावर 3। ठीक है, तो टोटल टाइम हमें आइडेंटिफाई करना है 4 मिलियंस ऑफ डेटा फाइल को सेंड करने के लिए। तो यहाँ पर जो सेंडर सेंड करना चाह रहा है वो फाइल साइज हमारे पास क्या है, द फाइल साइज इज 4 मिलियन, राइट, 4 मिलियन। अब यहां से अगर हम इसको ब्रेक करें तो ये हो जाएगा 4 इंटू 4 मिलियन, दिस इज द बाइट, राइट। सो 4 इंटू 10 टू द पावर 6 बाइट्स। ठीक है, देखिए लॉजिकली चीजें क्या बोल रहा है, लॉजिकली चीजें बोल रहा है कि ऑब्वियस सी बात है, यहां पर सबसे पहले हम लोग इस पर्टिकुलर पॉइंट से फाइल को ट्रांसफर करेंगे, तो इट विल टेक t1 टाइम। ऑब्वियसली द फाइल विल बी प्रोपागेटेड, सो इट विल टेक द प्रोपागेशन टाइम जो हमें नेग्लिजिबल दिया हुआ है। ठीक है, सो अगेन व्हेनेवर द पैकेट विल कम ओवर हियर, द राउटर R1 विल प्रोसेस इट आफ्टर स्टोरिंग एंड देन इट विल बी फॉरवर्डेड। तो यहां से फॉरवर्ड करने में जो टाइम लग रहा है, सपोज दिस इज t2, दिस इज द ट्रांसमिशन टाइम, अगेन इट विल बी प्रोपागेटेड एंड देन इट विल बी ट्रांसमिटेड। तो ये हो गया हमारा t3 एंड अगेन इट विल बी प्रोपागेटेड। तो प्रोपागेशन में जो टाइम लग रहा है, सो दिस इज द tp एंड दिस इज अगेन tp, एंड वंस द पैकेट विल रिसीव बाय द राउटर, सो राउटर विल स्पेंड सम टाइम ओवर प्रोसेसिंग, जो कि हमें क्या दिया हुआ है, टेंडिंग टू 0 दिया हुआ है। तो यहां पर मेरे दोस्त हमारा जो प्रोसेसिंग टाइम है इट इज गिवन एज टेंडिंग टू 0, एंड जो प्रोपागेशन डिले है दिस इज ऑल्सो गिवन एज टेंडिंग टू 0। तो ऑब्वियस सी बात है, अगर हम टोटल टाइम की बात करें, टोटल टाइम की अगर हम लोग बात करें, तो यहां पर टोटल टाइम आएगा ट्रांसमिशन टाइम, दैट इज द t1 प्लस t2 एंड प्लस t3। इसमें कोई कॉम्प्रोमाइज नहीं होने वाला है, क्योंकि ये बहुत ही स्ट्रेट फॉरवर्ड चीजें हैं और इस पे हम लोग कोई चेंजेस नहीं कर सकते हैं। ऑब्वियसली सोर्स नोड भी ट्रांसमिट करेगा, राउटर R1 भी ट्रांसमिट करेगा, राउटर R2 भी ट्रांसमिट करेंगे, एंड देन द पैकेट विल रीच टू द डेस्टिनेशन होस्ट। अब सिचुएशंस की बात करते हैं। सिचुएशन में देखिए टाइम कम होने का पॉसिबिलिटी तभी है जब आप पैकेट को फ्रेगमेंट करते हैं, राइट। सो इफ यू आर ट्राइंग टू फाइंड आउट द ऑप्टिमल नंबर ऑफ पैकेट हुज फॉर्मूला इज लाइक x into k-1 divided by h. So my dear friends, until and unless we know the size of header, obviously x हमारा क्या है, x हमारा यहाँ पर है फाइल साइज, राइट, जो हमें पता है, जो हमें क्या है पता है। ठीक है, k हमारा क्या है, दिस इज द नंबर ऑफ हॉप्स, नंबर ऑफ हॉप्स जो कि हमारा नोन है। h हमारा क्या है, सो दिस इज द हेडर साइज, दिस इज द हेडर साइज जो कि हमारा अननोन है, हेडर साइज हमें नहीं पता। तो अगर हमें हेडर साइज नहीं पता तो हम p के वैल्यू को कैलकुलेट नहीं कर सकते। p इज द ऑप्टिमल नंबर ऑफ पैकेट्स, राइट, ऑप्टिमल नंबर ऑफ पैकेट्स, राइट। p हमारा ऑप्टिमल नंबर ऑफ पैकेट्स है, और ये तब तक हम लोग कैलकुलेट नहीं कर सकते हैं जब तक हमें हेडर का साइज पता ना हो। ये एक पॉसिबिलिटी था कि अगर आप पैकेट को सेंड कर रहे हैं तो इन दैट सिनेरियो if you are doing the fragmentation, the time could be minimized, but since no information is given about the header, we can't do anything, right। हम लोग यहाँ पर कुछ नहीं कर सकते क्योंकि हम लोगों ने बहुत सारे PYQ को सॉल्व किया है, मींस वी आर चैलेंजिंग द अर्लियर PYQ, जो हम लोग पहले PYQ क्वेश्चन को हम लोगों ने सॉल्व किया है। अगर हम लोग यहाँ पर गलती करते हैं तो हम उन सारे क्वेश्चंस को चैलेंज कर रहे हैं। आर यू गेटिंग माय पॉइंट और नॉट? सो एक बात तो तय है कि यहाँ पर जो टोटल ट्रांसमिशन टाइम होगा वो ये होगा। अब ऑब्वियस सी बात है, क्योंकि 3 अलग अलग लिंक के ट्रांसमिशन जो बैंडविड्थ है वो डिफरेंट है, तो ट्रांसमिशन टाइम भी हमारा क्या होगा, वेरी करेगा, राइट। और इन सभी में से हमारा सबसे मिनिमम जो बैंडविड्थ है वो ये है, इससे हमारे टोटल टाइम में कोई फर्क नहीं पड़ने वाला है। ऑब्वियस सी बात है व्हेनेवर R2 will try to send the data packet, the minimum time will be taken over this particular link, like maximum time will be taken by this particular link। तो ये एक ऐसा लिंक है जहां पर पैकेट को ट्रांसमिट करने में सबसे ज्यादा टाइम लगेगा, ठीक है ना, सबसे ज्यादा टाइम लगेगा। क्यों? क्योंकि बैंडविड्थ हमारा मिनिमम है, और हम जानते हैं कि जो ट्रांसमिशन टाइम होता है दैट इज द TF, दिस इज बेसिकली कैलकुलेटेड बाय L अपॉन R, जहां पर L हो गया हमारा फाइल साइज और ये हो गया हमारा बैंडविड्थ। तो फाइल साइज हमें दिया हुआ है 4 इंटू 10 टू द पावर 6, ये बाइट के फॉर्म में है। और बीच वाले पार्ट से अगर हम कैलकुलेट करें तो दिस इज द 500 kbps मींस 10 टू द पावर 3, ये हमारा है बिट्स पर सेकंड, राइट। राइट। तो ये 3 जीरो से ये सभी कट जाएंगे, ठीक है ना, सभी कट जाएंगे। और ऊपर में हमारे पास क्या आ रहा है, ऊपर में हमारे पास आ रहा है 4 इंटू 8, 8 ये हो गया हमारा बिट्स, बिट्स, ठीक है, 4 इंटू 8 बिट्स डिवाइडेड बाई वी हैव अ 5 bits per second, right? 5 bits per second. Is it correct? Is it correct? Right. Okay. ऊपर वाले पार्ट में 10 आवर होगा, राइट, ये वाला पार्ट में 10 आवर होगा, ठीक है। 5 जीरो हमने कैंसिल कर दिया, तो दिस इज द 4 इंटू 10 इंटू 8, ठीक है। नीचे है हमारा 5, तो ये 5 से ये 2 टाइम जाएगा, ठीक है ना। 8 चौके 32 दूना 64, तो ये आ जाएगा हमारा 64 सेकेंड। ऑब्वियस सी बात है कि जो मिनिमम टाइम होगा वो 64 सेकेंड होगा, ठीक है ना, इंटरमीडिएट लिंक पे। लेकिन अगर हम टोटल टाइम की बात करें तो वो कभी भी 64 सेकेंड नहीं हो सकता है, जो हमारा गेट यहाँ पर आंसर क्लेम कर रहा है, ठीक है ना, गेट हमारा आंसर क्लेम कर रहा है। तो इस क्वेश्चन को हम लोग चैलेंज कर सकते हैं, ठीक है ना। मैंने पर्सनली गेट को मेल भी डाला है कि इस क्वेश्चन का सही आंसर क्या होगा, आप एक बार क्रॉस वेरीफाई करके बताइए, ठीक है ना, या व्हाट विल बी द आइडिया। सी वी आर अ टीचर, वी आर ऑल्सो इन अ लर्निंग फेज, राइट। और हम लोग जो कॉन्सेप्ट जानते हैं, जिससे हम लोगों ने अभी तक बहुत सारे पीवाईक्यू को सॉल्व किया है, अगर हम इसको गलत तरीके से सॉल्व करें, इसका मतलब है कि हम उन सारे क्वेश्चंस को चैलेंज कर रहे हैं। आर यू गेटिंग माय पॉइंट और नॉट, ठीक है ना, क्योंकि बेसिक सा एस्पेक्ट है, यहाँ पर हम बहुत ज्यादा ट्विस्ट करके नहीं सोच सकते, ठीक है ना, कि तीनों में से जो मैक्सिमम होगा उसको कंसीडर कर लो, ठीक है, क्योंकि ट्रांसमिशन हर एक नोड पे होना तय है, और हमसे टोटल ट्रांसमिशन टाइम के बारे में पूछा जा रहा है, ना कि मैक्सिमम ट्रांसमिशन टाइम। सो स्टिल देयर इज अ लाइक प्रॉब्लम इन दिस पर्टिकुलर क्वेश्चन, बट बहुत सारे स्टूडेंट ने ऑप्शन बी को टिक किया है, बहुत सारे स्टूडेंट ने जिन्होंने भी पेपर दिया उन्होंने ऑप्शन बी को टिक किया है, तो अकॉर्डिंग टू द गेट आंसर की उनका आंसर सही है। बट स्टिल वी कैन मेक अ चैलेंज ओवर दिस क्वेश्चन, राइट। सो हम लोग इसको एक बार और कभी देखेंगे जब हमारा पास फाइनल इसका गेट से रिप्लाई आएगा, ठीक है। चलिए दूसरे क्वेश्चन की तरफ बात करते हैं। ये एप्लीकेशन लेयर का बहुत ही सिंपल सा क्वेश्चन है, एंड इस तरह के क्वेश्चंस को हम लोगों ने बहुत बार क्लास में सॉल्व भी किया है। चलिए देखते हैं क्या बोला जा रहा है। विच ऑफ द फॉलोइंग प्रोटोकॉल मे नीड टू ब्रॉडकास्ट सम ऑफ इट्स मैसेजेस, अपने मैसेजेस को ब्रॉडकास्ट करने की जरूरत पड़ेगी किस प्रोटोकॉल के अंदर। सबसे पहला दिया हुआ है SMTP। देखिए हमें पता है कि सिंपल मेल ट्रांसफर प्रोटोकॉल इट इज यूज्ड टू सेंड अ मेल वाया क्लाइंट टू द सर्वर। ऑब्वियसली यहाँ पर हम कोई चीज ब्रॉडकास्ट नहीं कर रहे हैं, वी आर सिंपली सेंडिंग अ मेल टू द सर्वर एंड वी आर नॉट डूइंग एनी ब्रॉडकास्टिंग, वी आर नॉट डूइंग एनी ब्रॉडकास्टिंग, फाइन, ब्रॉडकास्टिंग। तो यहाँ पर हम लोग कोई ब्रॉडकास्टिंग नहीं कर रहे हैं, तो ये ऑप्शन नहीं हो सकता है। FTP इज द फाइल ट्रांसफर प्रोटोकॉल एंड वी आर सिंपली सेंडिंग अ फाइल, वी आर नॉट डूइंग एनी ब्रॉडकास्टिंग। DHCP जो मेरे दोस्त प्रोटोकॉल है, दिस इज द डायनेमिक होस्ट कॉन्फ़िगरेशन प्रोटोकॉल। मैंने आपको क्लास में भी बार बार बताया था, जब हम लोग का मैराथन सेशन हो रहा था वहां पर भी मैंने आपको बताया था। DHCP इज बेसिकली यूज्ड टू कैप्चर द IP एड्रेस बेसिकली इन अ वायरलेस नेटवर्क, ठीक है ना, डायनेमिक होस्ट कॉन्फ़िगरेशन प्रोटोकॉल। सो होता क्या है कि एक राउटर से बहुत सारे वायरलेस नेटवर्क पे नोड कनेक्टेड है, एंड सपोज यू आर ट्राइंग टू एंटर इनटू दैट पर्टिकुलर नेटवर्क। सो व्हाट विल हैपन, द राउटर विल सेंड मेनी IP एड्रेसेस, राइट। सो राउटर क्या करता है, उस IP एड्रेस को ब्रॉडकास्ट करता है, और जो भी नोड उस नेटवर्क पे एंटर कर रहा है, द नोड विल कैप्चर दैट पर्टिकुलर IP एड्रेस। सो फर्स्ट कम फर्स्ट सर्व वाला कॉन्सेप्ट होता है। सो यू आर विजिटिंग इन अ वायरलेस नेटवर्क, सो ऑब्वियसली टू एक्सेस द इंटरनेट यू नीड अ IP एड्रेस. So router will simply broadcast the IP address and the node who is first visiting to that network will capture it. Obviously कोई नोड वहां से बाहर भी निकल रहा होगा, तो वो बाहर अगर निकलता है तो वो जो IP एड्रेस है वो फ्री हो जाता है। तो बेसिकली होता क्या है, ठीक है ना, ये हमारा पूरा नेटवर्क है और इस नेटवर्क पे ये हमारा डिवाइस है, ठीक है ना, ये हमारा क्या है, डिवाइस है। तो यहाँ से एक IP एड्रेस क्या हो रहा है, ब्रॉडकास्ट हो रहा है, और अगर कोई भी नोड यहाँ पर आ रहा है तो वो इस IP एड्रेस को कैप्चर करेगा, एंड इफ यू आर लिविंग द नेटवर्क यू विल फ्री द IP एड्रेस। ये फ्री करेगा और ये कैप्चर करेगा, राइट, ये कैप्चर करेगा। सो अ नोड विच इज विजिटिंग टू दिस नेटवर्क विल कैप्चर द न्यू IP एड्रेस विच इज ब्रॉडकास्टेड बाय दिस डिवाइस। और कोई अगर डिवाइस इस नेटवर्क को लीव कर रहा है तो ऑब्वियसली दैट पर्टिकुलर IP एड्रेस विल गेट फ्री, एंड द राउटर कैन assign this IP address which is free by this node to any other node who is visiting to this network. So obviously DHCP is the correct answer. ठीक है, लास्ट में दिया हुआ है HTTP. HTTP जो है ये बेसिकली वेब पेज एक्सेस करने के लिए हम लोग यूज करते हैं. द क्लाइंट यूज दिस प्रोटोकॉल टू एक्सेस द वेब पेजेस फ्रॉम द वेब सर्वर. सो दिस इज नॉट अ पॉसिबल आंसर. ठीक है, ये सभी क्लाइंट सर्वर आर्किटेक्चर है. ये जितने भी प्रोटोकॉल्स है HTTP, FTP, SMTP, these are the client server architecture which are used to access the something from the web server, right? So let's go to the next question. अब ये बहुत ही आसान सा क्वेश्चन था, ठीक है ना, बहुत ही आसान सा क्वेश्चन था. कंफ्यूजिंग टर्म क्या था? कंफ्यूजिंग टर्म यहाँ पर था नेटवर्क इंटरफेस. क्योंकि अभी तक जो हम लोग सुनते आ रहे थे दैट इज द नंबर ऑफ होस्ट. ये आइडेंटिफाई करना, सभी का आंसर की यहाँ पर दिए हुए जो ऑफिशियली गेट ने अनाउंस किया है, ठीक है ना. तो अभी तक हमें पता था कि नंबर ऑफ होस्ट कितने होंगे, इसको आइडेंटिफाई करना, क्योंकि लुकिंग एट द सबनेट मास्क, सी 8, 8 and 4. So looking at the subnet mask, you can easily predict this is the /20, मतलब कि 20 बिट पे मास्किंग है. तो हमारे पास फ्री अवेलेबल बिट्स कितने हैं? तो अवेलेबल बिट्स है 32 minus 20 is equal to 12 बिट्स. 12 बिट्स हमारे पास क्या है? अवेलेबल है टू जस्ट गिव द IP एड्रेस टू द डिफरेंट होस्ट, राइट. तो अभी तक हमें पता था कि नंबर ऑफ होस्ट कैसे आइडेंटिफाई करना, बट यहां पर दिया हुआ है the maximum number of IP addresses that can be assigned to the network interface is. तो मेरे दोस्त, I hope you remember this diagram. इस डायग्राम आपको याद होगा, ठीक है ना. इस डायग्राम में ये जितने भी होस्ट है, ऑब्वियसली दिस इज द राउटर एंड दिस इज द आउट ऑफ द नेटवर्क, राइट. ये आउट ऑफ द नेटवर्क है और ये सभी हमारे क्या है? होस्ट है. ये सभी हमारे क्या है? दिस आर द होस्ट. पहला IP एड्रेस हम लोग नेटवर्क को देते हैं और लास्ट वाला IP एड्रेस दैट इज द .255, राइट. So this one will be assigned to the, like this one will be reserved for the broadcasting, ठीक है. ये हमारा ब्रॉडकास्ट ID होता है और ये हमारा यहाँ पर नेटवर्क ID होता है. This is the network ID and remaining all the IP addresses starting from .1, .2, .3 to .254, these are assigned to the host. और ये होस्ट कैसे कनेक्टेड है? तो ये जितने भी होस्ट है ये सभी एक इंडिविजुअल इंटरफेस से कनेक्टेड है. आर यू गेटिंग माय पॉइंट और नॉट? All these hosts are connected through a interface. ये जो IP एड्रेस है ये किसी इंटरफेस से कनेक्टेड नहीं होता है, ये राउटर का IP एड्रेस होता है. ब्रॉडकास्ट ID किसी इंटरफेस से कनेक्टेड नहीं होता है, ठीक है ना. ब्रॉडकास्ट ID एक ID होता है जो इस नेटवर्क के अंदर हम लोग ब्रॉडकास्टिंग के लिए यूज करते हैं. आर यू गेटिंग माय पॉइंट और नॉट? बात समझ में आ रहा है, ठीक है ना. लेकिन ये जितने भी होस्ट हैं जो इस पर्टिकुलर नेटवर्क के अंदर है वो सभी एक ना एक कहीं ना कहीं इंटरफेस से क्या है? कनेक्टेड है. ये सभी पर्टिकुलरली इंटरफेस से कनेक्टेड है, ठीक है. तो अगर हमसे पूछा जा रहा है द नेटवर्क इंटरफेसेस, देन इट विल सिंपली बिकम 2^12 minus 2. दिस इंप्लाइज 4094 will be the correct answer. So if they are asking about the number of interfaces, so basically this term is equivalent to the number of host. बात समझ में आ रहा है, ठीक है ना. तो ये सभी इंटरफेस से कनेक्टेड हमारे होस्ट हैं, ठीक है. और नेटवर्क ID किसी पर्टिकुलर इंटरफेस को नहीं मिलता है, वो एक राउटर का नेटवर्क ID होता है. सिमिलरली ब्रॉडकास्ट ID किसी इंटरफेस का ID नहीं होता है, वो पूरे नेटवर्क पे ब्रॉडकास्ट के लिए हम लोग क्या करते हैं? यूज करते हैं. बात समझ में आ रहा है. सो द राइट आंसर विल बी द 4094. फाइन. सो लेट्स कम टू द नेक्स्ट क्वेश्चन. चलिए, ये एक बहुत ही आसान सा क्वेश्चन था, उस समय भी हम लोगों ने सॉल्व किया था, ठीक है ना. ये एरर डिटेक्शन टेक्निक जो CRC प्रोटोकॉल है उससे रिलेटेड बहुत ही बेसिक सा क्वेश्चन है. तो एक बार फिर से इसको सॉल्व करने की कोशिश करते हैं और देखते हैं इसका सही आंसर क्या होगा. आई होप मैक्सिमम स्टूडेंट जो अभी इस सेशन को देख रहे हैं उन्होंने सही आंसर क्या होगा, आई बिलीव दैट, राइट. सो लेट्स लुक एट इट. कंसीडर द ट्रांसमिशन ऑफ द डेटा दिस ओवर द लिंक यूजेस द साइक्लिक रिडंडेंसी चेक कोड फॉर द एरर डिटेक्शन. CRC हम लोग एरर डिटेक्शन के लिए यूज करते हैं. इफ द जनरेटर बिट्स पैटर्न इज दिस, इस बिट पैटर्न को हमें देख करके लग रहा है दिस इज नथिंग बट x⁻³ + 1. पॉलिनोमियल में हम लोग लिख सकते हैं. विच वन ऑफ द फॉलोइंग ऑप्शन शोज द रिमाइंडर बिट्स पैटर्न अपेंडेड टू द डेटा बिट्स बिफोर ट्रांसमिशन. ऑब्वियसली whenever you are creating a code word, so what exactly you do, you just divide the data word by the generator polynomial and whatever the remainder you are capturing, you simply append this part to the actual data word to create a code word which will be transmitted over the medium, right. ये हम लोग सिंपल सा फंडा है, जानते हैं, ठीक है ना. तो सिंपली हमें क्या करना है कि जो हमारे पास जनरेटर है उसको इससे उसको यूज करके इस पर्टिकुलर डेटा बिट्स को क्या करना है, डिवाइड करना है और हमें रिमाइंडर आइडेंटिफाई करना है. सो 0 0 0 दिस इज 1 0 1 1. 3 बिट्स हम लोग क्या करेंगे, अपने मन से अपेंड करेंगे जो हमें आइडेंटिफाई करना है, ठीक है. फाइन. सो लेट्स लुक एट इट. 1 0 0 1. So this one will become 1 0 1, right. एक और जीरो लेंगे 1 0 0 1. तो यहाँ पर ये आ जाएगा हमारा 1 1. यहाँ तक का पार्ट हमने ले लिया है, ठीक है। सो अगेन दिस इज 1 0, सो दिस इज 1 0 0 1, सो दिस वन विल बिकम 1 1 1, राइट। ये हमने ले लिया है, इसको भी लेते हैं, ठीक है। तो 1 0 0 1, सो अगेन दिस वन विल बिकम, ठीक है। ये हमारा क्या हो जाएगा, ये हो जाएगा 1 1 1, ठीक है। अब यहाँ पर ये आ गया हमारा 1, ठीक है। तो ये हमने 1 ले लिया, तो 1 0 0 1, तो यहाँ पर अब इसको हम यहाँ पर लिख रहे हैं, तो ये आ जाएगा हमारा 1 1 0, ठीक है। फिर से हमने एक 1 लिया, तो ये हो जाएगा 1 0 0 1, तो फाइनली वी विल हैव 1 0 0। अब इस 0 को लेंगे तो ये हो जाएगा 1 0 0 1, सो फाइनली वी विल हैव अ 1, और लास्ट में 2 0 है तो यहाँ पर 2 0 लगा दिए, तो ये हो गया हमारा रिमाइंडर, ठीक है। सो व्हेनेवर द सेंटर विल सेंड द डेटा, सो द कोड वर्ड विल बी, ऑब्वियसली जो अपेंड होगा वो हमारा रिडंडेंट बिट अपेंड होगा, तो कोड वर्ड क्या बन जाएगा, तो दिस इज 1 1 0 0 0 0 1 0 1 1, और ये जो 3 बिट है दिस इज 1 0 0 विल बी अपेंडेड, so the right answer of this question will become D, ठीक है। बहुत ही सिंपल सा क्वेश्चन है, एंड आई होप सभी स्टूडेंट ने इसका सही आंसर क्या होगा। ये थोड़ा सा इंटरेस्टिंग क्वेश्चन है, इस क्वेश्चन में दिमाग क्या लगाना है वो अभी हम लोग डिस्कस करने वाले हैं। चलिए देखते हैं क्या बोला जा रहा है। कंसीडर अ न्यू टीसीपी कनेक्शन। देखिए ये बहुत ही आसान लेवल का क्वेश्चन है, ऐसा नहीं है कि ऐसे क्वेश्चन हम लोगों ने कम से कम 25-30 बार किए हैं, ठीक है ना। whenever we were dealing with the congestion control protocol we have solved it multiple times, but what is the twist you need to think about it, ठीक है। चलिए क्या दिया हुआ है, consider a new TCP connection between a sender and receiver, the receiver advertised window size is 48 किलोबाइट, ठीक है, 48 किलोबाइट, the maximum segment size is 2 किलोबाइट। तो देखिए 1 MSS का वैल्यू हमें कितना दिया हुआ है, this is given as 2 किलोबाइट, ठीक है। तो इसका मतलब है जो एडवर्टाइज विंडो होगा, एडवर्टाइज विंडो साइज होगा वो हमारा कितना हो जाएगा एमएसएस के फॉर्म में, ये कितना हो जाएगा, ये हो जाएगा 24 MSS। ये बात क्लियर है, ठीक है ना, ये बात क्लियर है। चलिए उसके बाद क्या बोला जा रहा है, एंड द स्लो स्टार्ट थ्रेशोल्ड फॉर द टीसीपी कनेक्शन इज 16 किलोबाइट। तो एसएस थ्रेश हमारा कितना हो जाएगा मेरे भाई, तो एसएस थ्रेश हो जाएगा, दिस इज गिवन एज 16 किलोबाइट, इट मींस 8 MSS, ठीक है। ये हो जाएगा हमारा एसएस थ्रेश। अब क्वेश्चन क्या है, एज्यूम देयर इज नो टाइम आउट और द डुप्लीकेट एक्नॉलेजमेंट, कोई टाइम आउट नहीं हो रहा है, कोई डुप्लीकेट एक्नॉलेजमेंट नहीं है। द नंबर ऑफ राउंड्स ऑफ ट्रांसमिशन, ये बहुत ही इंपॉर्टेंट स्टेटमेंट है, इसको थोड़ा सा एक बार ऑब्जर्व करना है। द नंबर ऑफ राउंड्स of transmission required for the congestion control algorithm of the TCP connection to reach the congestion avoidance phase, ठीक है ना। कंजेशन अवॉइडेंस फेज को रीच करने के लिए कितने नंबर ऑफ ट्रांसमिशन हमें चाहिए। तो आप इसको ऐसे सोचो कि एक बंदा जो प्रोटोकॉल को ऑब्जर्व कर रहा है, ठीक है ना, एक बंदा प्रोटोकॉल को ऑब्जर्व कर रहा है, वो कितने राउंड ऑफ ट्रांसमिशन के बाद, मतलब कि कितने आरटीटी के बाद वो ये देखेगा कि कंजेशन अवॉइडेंस का फेज स्टार्ट हुआ है। तो समझना बात को, ठीक है, समझना बात को। ऑब्वियसली आपको ऑब्जर्व करना है कि कितने राउंड ऑफ ट्रांसमिशन का मतलब क्या हो गया, राउंड ऑफ ट्रांसमिशन का मतलब क्या हो गया, राउंड ऑफ ट्रांसमिशन का बेसिकली मतलब है यहां पर RTT, मतलब कितने आरटीटी के बाद, ठीक है ना। आप ये पता कर पाओगे कि जो प्रोटोकॉल है वो कंजेशन अवॉइडेंस फेज में है। तो हमें पता है कि इनिशियल जो कंजेशन विंडो साइज होता है, वो क्या होता है 1 MSS। तो इनिशियल कंजेशन विंडो का साइज है 1 MSS, ठीक है, 1 MSS। तो टिल SS थ्रेश द ग्रोथ विल बी एक्सपोनेंशियल, राइट। तो 1 के बाद ये होगा 2 के बाद होगा ये 4 और 4 के बाद होगा ये 8। ऑब्वियस सी बात है, सिंस दिस इज गिवन एज SS थ्रेश, हमारा यहाँ पर क्या दिया हुआ है 8 MSS, ठीक है। ये हमारा RTT है, दिस इज द RTT। तो समझना, दिस इज हैपनिंग इन द फर्स्ट RTT, दिस इज हैपनिंग इन द सेकेंड RTT एंड दिस इज हैपनिंग इन द थर्ड RTT, ठीक है, थर्ड RTT। तो फर्स्ट RTT में कंजेशन विंडो का साइज 2 हुआ है, उसके बाद 4 हुआ है, उसके बाद 8 हुआ है। हमें पता है ये स्लो स्टार्ट फेज है, क्या इस पॉइंट ऑफ टाइम पे अगर आप इस प्रोटोकॉल को ऑब्जर्व कर रहे हैं, ठीक है ना, सपोज यू आर ऑब्जर्विंग अ सिमुलेटर, ठीक है, तो आप इस पॉइंट ऑफ टाइम पे आप ये कभी भी पता कर पाएंगे कि ये कंजेशन अवॉइडेंस फेज में है या नहीं है? नहीं, कभी पता नहीं कर पाएंगे, क्योंकि अभी तक हमें जो ग्रोथ मिला है वो एक्सपोनेंशियल मिला है, राइट। सपोज यू डू नॉट हैव अ आइडिया अबाउट द एसएस थ्रेस एंड ऑल, ठीक है, आपको ये नहीं पता कि एसएस थ्रेस क्या है, यू आर सिंपली ऑब्जर्विंग द प्रोटोकॉल, राइट। So at this point of time, you are unable to claim whether the congestion avoidance phase has been started or not. So obviously, in the next round of transmission, whenever the congestion window size will become 9, obviously this is the fourth transmission. So जब भी आप इस शिफ्ट को ऑब्जर्व करेंगे कि यहाँ पर कंजेशन विंडो साइज जो है वो बेसिकली 8 से 9 की तरफ स्विच किया है, 8 से 9 की तरफ स्विच किया है immediately. At this point, you can claim that this is the congestion avoidance. This is the congestion avoidance. Are you getting my point or not? Congestion avoidance. You can easily claim. Means at the fourth transmission, you are able to claim that the congestion avoidance phase has been started. Are you getting my point or not? तो चौथे ट्रांसमिशन में जा करके देखिए, इस पॉइंट तक आप ये नहीं क्लेम कर पा रहे हो कि ये कंजेशन स्लो स्टार्ट फेज है या कंजेशन अवॉइडेंस फेज है, बिकॉज सिंस द विंडो साइज इज इंक्रीजिंग एक्सपोनेंशियली, सो यू आर अनेबल टू से वेदर द कंजेशन अवॉइडेंस फेज हैज बीन स्टार्टेड और नॉट. बट एज सुन एज यू विल ऑब्जर्व द विंडो साइज शिफ्टिंग फ्रॉम 8 to 9, क्योंकि देखिए जब आप सिमुलेटर को ऑब्जर्व करते हैं ना, जब आप सिमुलेटर को ऑब्जर्व करोगे तो सिमुलेटर में आपने देखा विंडो साइज 1 है, फिर 2 हो रहा है, फिर 4 हो रहा है, फिर 8 हो रहा है, तो यहां तक आपको लग रहा है कि अभी भी स्लो स्टार्ट फेज है, अभी भी क्या है, स्लो स्टार्ट फेज है. बट व्हेनेवर यू विल फाइंड दिस शिफ्ट, you can immediately claim this is the congestion avoidance phase, right? So whenever you will find the window size is increasing by 1, it means it is a congestion avoidance phase, it is not slow start phase. So to claim with the 100% surety that the congestion avoidance phase has been started, you have to observe this scenario, right? So how many RTTs we will require to claim this, that the congestion avoidance phase has been started, is the 4 RTT. तो ये एक न्यूमेरिक टाइप क्वेश्चन था जहां पर आपको आंसर पुट अप करना था. दिस इज 4. फाइन. सो लेट्स गो टू द नेक्स्ट क्वेश्चन. अब ये बड़ा ही इंटरेस्टिंग क्वेश्चन है. इसमें कुछ रिडंडेंट इंफॉर्मेशंस है, इसमें कुछ हमारे पास रिडंडेंट इंफॉर्मेशंस हैं जो हमें इग्नोर करना था. हालांकि इसको हम यूज भी करते हैं, ठीक है ना, उसको हम लोग यूज भी करेंगे. देखिए एक बात तो तय है कि अगर हमें रैप अराउंड टाइम दिया हुआ है, ठीक है ना, अगर हमें सी क्या दिया हुआ है, द सीक्वेंस नंबर डू नॉट रैप अराउंड बिफोर 60 सेकेंड, ठीक है ना, 60 सेकेंड के पहले जो हमारा सीक्वेंस नंबर है वो कभी भी रैप अराउंड नहीं होगा. ऑब्वियसली बाकी के जो इंफॉर्मेशन है, जैसे कि हम लोग क्या करते हैं, बाकी ये हमारा क्लाइंट है और ये हमारा सर्वर है, तो इस क्लाइंट और सर्वर के बीच में, ठीक है ना, मैक्सिमम कितने बाइट्स एकोमोडेट हो सकते हैं, नंबर ऑफ बाइट्स एकोमोडेटेड, ठीक है, ये तो हम लोग पता करेंगे कितने बाइट्स एकोमोडेट हो रहे हैं, ठीक है ना, सेंडर और रिसीवर के बीच. तो ऑब्वियसली यहाँ पर ये टीपी टाइम लग रहा है, यहाँ पर भी ये टीपी टाइम लग रहा है, तो टोटल नंबर ऑफ बाइट्स, तो दिस इज कॉल्ड बैंडविड्थ डिले प्रोडक्ट, राइट, बैंडविड्थ डिले प्रोडक्ट. अगर हमें बैंडविड्थ पता है तो दिस इज द आर इंटू 2 TP, राइट, दिस इज R इंटू 2 TP. तो हमारा बैंडविड्थ डिले प्रोडक्ट क्या आएगा, R इंटू 2 TP. सो इफ यू हैव अ नॉलेज अबाउट द प्रोपागेशन डिले एंड यू हैव अ नॉलेज अबाउट द बैंडविड्थ, सो यू कैन इजिली आइडेंटिफाई हाउ मेनी बाइट्स कैन बी accommodated inside the channel, and accordingly you can think of it that the client is going to decide how many bytes the client has to send. But the twist is client server architecture में सर्वर के पास अवेलेबल एडवर्टाइज विंडो होता है, तो सिर्फ ये सोचना सफिशिएंट नहीं है कि कितने बाइट्स चैनल में एकोमोडेट हो सकते हैं, क्योंकि एडवर्टाइज विंडो साइज पे ये डिपेंड करता है कि जो सर्वर है वो कितने बाइट को स्टोर कर सकता है, और ये बेसिकली डिसाइड होता है रैप अराउंड टाइम से, बात समझ में आ रहा है, रैप अराउंड टाइम से कि कितने बाइट्स जो क्लाइंट है वो बेसिकली कितने मैक्सिमम बाइट जो है वो क्लाइंट हमारा ट्रांसमिट कर सकता है. जैसे कि हम लोग जब डेटा लिंक लेयर पढ़ते हैं तो डेटा लिंक लेयर में एडवर्टाइज विंडो साइज जो है वो बहुत ज्यादा नहीं होता है, क्योंकि स्लाइडिंग विंडो प्रोटोकॉल में सेंडर और रिसीवर का जो विंडो साइज होता है वो फिक्स होता है, राइट। सो वी डू नॉट हैव अ आइडिया अबाउट, क्योंकि मैंने आपको वहां पर बताया था डेटा लिंक लेयर में द रिसीवर विंडो साइज इज नॉट फ्लेक्सिबल, इट इज ऑलवेज फिक्स्ड। और वो चूंकि ऑलवेज फिक्स्ड होता है तो बेसिकली वी कंप्यूट दिस टू आइडेंटिफाई हाउ मेनी फ्रेम्स कैन बी अकोमोडेटेड इनसाइड द चैनल, right? But in this scenario, in client server architecture, at the receiving end we have advertised window size which is changing during the time, ठीक है ना, टाइम के अनुसार वो क्या होता है, वेरी करता रहता है, कभी बढ़ता है कभी घटता है। एंड दिस इज बेसिकली डिटरमाइंड बाय द रैप अराउंड टाइम, कितना रैप अराउंड हमारे पास टाइम है। तो बेसिकली जो दूसरा इंफॉर्मेशन है ये हमारा यहाँ पर रिडंडेंट इंफॉर्मेशन है, जो आपको इग्नोर करना था, जो यहाँ पर आपको कंफ्यूज करने के लिए दिया गया था। बात समझ में आ रहा है? तो उसके अकॉर्डिंगली अगर हम लोग देखें, उसके अकॉर्डिंगली हम देखें तो हमारा जो टीएफ टाइम होता है, ठीक है ना, तो टीएफ जो टाइम होता है विच इज बेसिकली रैप अराउंड टाइम, सो दिस इज एल अपॉन आर, ठीक है। तो एल का वैल्यू हमें क्या दिया हुआ है, तो दिस इज द 2 to the power n बाइट्स डिवाइडेड बाय व्हाट इज द बैंडविड्थ गिवन इन दिस क्वेश्चन, ठीक है ना। इस क्वेश्चन में हमारे पास बैंडविड्थ कितना दिया हुआ है, 2 to the power 8 बिट पर सेकेंड। तो यहाँ पर ये हो जाएगा 2 to the power 8 बिट्स पर सेकेंड, ये बाइट्स में है तो कन्वर्ट करेंगे तो ये हो जाएगा 2 to the power n plus 3 बिट्स एंड दिस इज 2 to the power, sorry I think this is 10 to the power, right, 10 to the power 8 bit, right. So this is basically a 10 to the power, this is basically a 10 to the power okay, sometime the screen hang, ठीक है, दिस इज 10 to the power 8 बिट पर सेकेंड, ठीक है। तो ये हो गया यहाँ पर हमारा, इसको फिर से हटाएंगे और यहाँ पर लिखेंगे दिस इज 10 to the power, जस्ट वेट अ सेकेंड, ठीक है, दिस इज 10 to the power 8। अब ये हो गया हमारा बिट्स पर सेकेंड। अब ये दोनों बिट्स कैंसिल होंगे और यहाँ पर टीएफ का वैल्यू कितना दिया हुआ है, 60 सेकेंड, तो ये 60 सेकेंड आपस में कैंसिल हो जाएगा। तो यहाँ पर हम लोग क्या लिख सकते हैं, 2 to the power n plus 3 इज इक्वल टू 60 इंटू 10 to the power 8। दोनों तरफ लॉग लेंगे तो यहाँ पर कितना आ जाएगा, दिस इज n plus 3 इज इक्वल टू लॉग ऑफ ऑन द बेस 2 60 इंटू 10 to the power 8, ठीक है। तो ऑब्वियसली चूंकि आप लॉग ले रहे हैं तो यू हैव टू कंसीडर दिस सेलिंग वैल्यू, सो हियर n इज इक्वल टू लॉग ऑफ 60 into 10 to the power 8 on the base 2 and selling value plus 3. So once you will compute it, you will get 30, right? यहाँ पर simply आपको क्या आंसर मिलेगा, 30 आंसर मिलेगा, right? Right? Is that clear? Fine. So the final answer of this question will become 30. 30. तो यहाँ पर ये न्यूमेरिक टाइप क्वेश्चन था जिसका सही आंसर हमारा क्या हो जाएगा, 30. Is that clear? Fine. So I think this was the last question in the shift 2 and we do not have any more question after it. So thank you very much. जो पहला क्वेश्चन है, जैसा कि मैंने आपको बोला है कि गेट अथॉरिटी को मैंने ऑलरेडी मेल किया हुआ है एंड वी आर वेटिंग फॉर द रिस्पॉन्स, ठीक है। एंड एज सुन एज आई विल रिसीव द रिस्पॉन्स डेफिनेटली वंस अगेन वी विल डिस्कस अबाउट इट, ओके। सो थैंक यू वेरी मच, बाय, जय हिंद, मस्त रहिए, मेहनत करिए और आगे बढ़िए।
Hi, let's see the solutions for operating system shift 2 to 2026. Which one of the following CPU scheduling algorithms cannot be preemptive? First come first serve naturally is non-preemptive, is it not? Cannot be preemptive. Whereas shortest remaining time first is inherently preemptive, round robin is preemptive, priority can also be preemptive. He's saying cannot be preemptive, priority can be preemptive. Okay, I have two versions of both priority, preemptive and non-preemptive. So the only choice is first come first serve. Next. Consider three processes P1, P2 and P3 running identical code as shown in the pseudocode below. A and B are two binary semaphores initialized to 1 and 0. A is initialized to 1, B is initialized to 0. So let me write A is 1 and B is 0. Okay. X is a shared variable initialized to 0. Each line in the pseudocode is executed atomically. Fine. So the typical code structure for P1, P2, P3 is wait on A, then print star, increment X. If X equal to 2, then only I say print dollars, then signal B, So point is, what the moment X become 2, compulsory you are going to print dollars, compulsory. After 2 stars, definitely dollars is going to come, that's the meaning. And after that I am saying signal B, but suppose if X is not 2, we are saying signal A, that means you release A, and wait on B. Here you get stuck. Then print hash, then signal B. Assume that any of the three processes can start to execute first, and context switching can happen between these processes in any arbitrary manner. Which of the following patterns is or are possible? These are MSQ, boys and girls. These are possible to be generated as an outcome of the execution of these three processes. So see here. So if I start with P1, wait on A, success, print star, we print star, x equal to x plus 1, condition fails. So we don't execute here. We say signal A, that means A become 1, wait on B, get stuck. So printing star, we get stuck. Now if I start with 2, okay, x is 1. So now we say we print another star, 2, second star. X equal to x equal to 1, x become 2. But before printing dollars, for example, if I get preempted and I start with P3, if I start with P3, wait on A will block. That's the important point. Wait on A will block for P3. So that means I cannot print third star. I cannot print third star. So first 2 stars has to mandatorily come. 2 stars has to mandatorily come. 3 stars cannot come. 3 stars cannot come. So definitely forcing us to print dollars after this. So definitely every output stream will start with the output with star star dollar. Star star dollar has to come. 3 stars is impossible. 3 stars is impossible. So star star dollar, star star dollar, star star dollar. Star, here I have 3 star, means this output is this option is totally gone. So can I have dollars? Yes, I can have dollars. After dollars, can I have third star? Yes, I can have third star. Why not? Third star can come. Third star can come. But after dollars, can hash can come? Yes, check it. After dollars, either star can come or hash can come. How? Let us see. So after dollars, how hash can come? Please check. How hash can come? After dollars, how hash can come? Star can come, that is option A is possible. And how hash can come? The hash can come like this. Star star dollar. After dollar, now without third process, I can come here, right? So signal on B is done. So that means I can wake up here. So I can have hash. Either 1 hash can come or 2 hashes can come. Either 1 hash can come or 2 hashes can come. Then definitely, okay. So 3 stars followed by 3 hash, this is also possible. And then hash followed by star should come, or 2 hashes then star. So therefore B and C, these 3 are possible. These 3 are possible. You can check that. In any order of preemptive execution between P1, P2, P3, I can definitely get options A, B, C. So the correct answer for this question is A, B, C. Okay, next. To keep track of free blocks in a file system, one of the 2 approaches is generally used, bitmaps or free list. Free list. This is called linked list, means free list. If you talk in terms of my notation, free list. Consider that the linked list approach is used to keep track of free blocks in a file system. Assume that the disk size is 16 GB, okay, block size is 2 KB. So how many blocks I will have? Number of blocks. Number of blocks is equal to 16 GB, 2 power 34 divided by block size. Block size is 2 KB, 2 power 11. 2 power 11. This is nothing but 2 power 23. 2 power 23. There are 2 power 23 blocks present in the disk. And a block number is 32 bits. So that means this block address is 32 bits, means 4 bytes. This block address is 4 bytes. A single pointer of size 4 bytes is also used in each block to point to the next block. So therefore, to point to the next block, this is also a 4 byte pointer. This is also a 4 byte pointer. Okay. Okay. The number of blocks required to hold the free disk block numbers. How many disk block addresses can be stored in one block? So first we'll calculate one block can store how many addresses. Block size is 2 KB. In 2 KB, how many 4 byte entries? How many? Because this block size is also 4 bytes. This block address 4 bytes. So therefore 2 power 9 by 2 power 11. 2 power 11 divided by 2 power 2, 2 power 9. Means one block can store 512 addresses, but one last address will be for next pointer, which is also 4 byte, one last. So effectively or essentially, I can store only 511 addresses. I can store only 511 addresses in one block. 511 addresses. In one block, I can store 511 addresses. How many addresses do I have? I have number of blocks 2 power 23. 2 power 23. 2 power 23 addresses need how many blocks? That's it. That's a computation. So you can put an equation, simple equation. One block can store 511 addresses. 511 addresses. I have 2 power 23. That means 8 mega addresses. 8 mega addresses need how many blocks? This is a simple calculation that I have to make. So 8 mega is 8 into 1024 into 1024 divided by 511. You take upper bound, because if it is point something, then basically you will have to take a round of it. You have to take a round of it with internal fragmentation. So if you calculate this value, boys and girls, if you calculate this value, this will come like 8 into 1024 into 1024 divided by 511. So 16417. 16417 blocks are needed. 16417 blocks are needed. So this is the answer for the question. Okay? As a numerical answer type, the answer for this question is 16417. Chalo, next. A system has a translation look-aside buffer that has a reach of 1 megabyte. TLB reach. If you remember my YouTube session, I have solved this question on TLB reach, fortunately, in most expected questions. Direct problem. TLB reach formula is nothing but number of entries in TLB. Number of entries in TLB. Number of entries in TLB multiplied by page size. Multiplied by page size. So TLB reach value is given as 1 megabyte. As a TLB reach of 1 megabyte is equal to number of entries, say n, into page size. Page size is how much? Page size is given to be 4 KB. So number of entries I got, number of entries is equal to 1 mega, which is 2 power 20 divided by 2 power 12, 2 power 8. So number of entries in TLB are 2 power 8. Okay. So he's asking size of the TLB is how much? So size of TLB size is equal to number of entries. Number of entries are 2 power 8 into entry size. Look at that. Entry size has what? If each TLB entry stores a 4-bit process ID, 4-bit process ID, page number. So what is page number? Look at that. 64 GB. Virtual address space is 64 GB, means 2 power 36 divided by page size 2 power 12. 2 power 12. So this is 36 minus 12, 4, 24. 24 plus 24 bits plus frame number. Physical address space is 1 GB, means 2 power 30. 2 power 30 by 2 power 12. So this is 18 bits. 18 bits plus frame number is 18 bits. 2-bit control field. 2-bit. So 20, 44, 48. 48 bits. 48 bits is 6 bytes into 6 bytes. So this is nothing but 2 power 8, 256. 6 into 256 bytes. 6 into 256 bytes. Okay. 6 into 256 bytes is the answer for it. So you can make a computation. 1536. 1536. So answer for this is 1536. Okay. Consider contiguous allocation of physical memory to processes using variable partitioning scheme. Suppose there are 8 holes in the memory of sizes 20 KB, okay, and all that. Assume that no 2 holes are adjacent, no 2 processes P1 of size 16 KB and P2 of size 9 KB. Okay, using best fit allocation policy. Using best fit. 16 KB will go into 18 KB. So here a new hole of size 2 KB will be created. And P2 of size 9 KB will go into 9 KB, 0. Okay, after allocating space to P1 and P2, the number of holes of size less than 8 KB, less than 8 KB 1 is 2, is 3. That's it. The answer for this is 3. As simple as that. 3 holes. Okay. The number of holes of size less than 3, less than 8 KB is 3. That's it. So that is the answers for shift 2. All right, let's see the solution for algorithm shift 2 of GATE 2026. Yes. Consider the following functions, n power 1 by 3 log n and log n factorial and 2 power log n. See, I have functions like n power 1 by 3 and I have log n, rate of growth, log n factorial. If you see log n factorial, many a time we have already seen it is theta of n log n, and the last function is 2 power log n. So using property of log, this is nothing but n log n. And using property of log, using asymptotic order, this is n log n and this is nothing but n. So if you see the order rate of growth, log will have the lesser rate of growth and n power 1 by 3, and n power 1 by 3 will be less than n and will be less than n log n. This is the correct asymptotic rate of growth. Is it not? So naturally, the option 1 matches with this. So therefore, the correct option is A. Chalo, next. Which one of the following can be the recurrence corresponding to an algorithm with time complexity of theta of n? It's a very simple question. This recurrence is, if you simplify using back substitution, will be order of n. Using master method, if you simplify, this also will be order of n. And using master method, if you simplify, this will be n log n. And if you simplify this, this will be order of n square. So naturally, when you say theta of n, so definitely option A and option B will be correct as an MSQ, So both A and B are correct. Chalo, next. Consider an array, the following array. Suppose the merge sort algorithm is executed on array A to sort it in increasing order. The merge sort algorithm will carry out a total of 7 merge operations because there are 10 elements. So there will be, 2 to 4, 5, 6, 7, 8 elements. So 7 merge operations are needed. And a merge operation on sorted left array L and sorted right array R is said to be void. If the output of the merge operation is the elements of array L followed by the elements of array without any swap, the number of void merge operations for these 7 elements is dash. So the elements are 10, 7, 8, 19. Let's write it here. Array is 10, 7, 8, 10, 7, 8, 19, 19, 41, 35, 41, 35, 25 and 31. 25 and 31. These are 8 elements. So when I do the merge operation, so first I will have a list with 4 elements. List with 4 elements, is it not? So the first 4 elements, I will have 10, 7, 8, 19, 41. The other side will have 31. I think 5 elements. These are 4 elements. And the other is 41, 35, 25, 31. So this has to be again divided. Okay. So this will get divided as 2 elements each, 10 and 7, and 8 and 19. And this will get divided as 41, 35, 25, 31. This will get divided as 10 and 7. And this will get divided as 8 and 19. This will get divided as 41 and 35. And this will get divided as 25 and 31. So now it comes to the matter of merge operation. These two are merged, but this is not void merge operation because we are having 7 and then 10. And this is one merge operation, one void operation, right? 8 and 19, they are in the order. So this is one void operation. Merge operation leading to void. Okay. And when I merge these two, 41 and 35, this is not void because 35 and 41 are coming up, 35 and 41. And these two are merged. This is another void merge operation, 25 and 31. 25 and 31. So this is another void merge operation. Okay. Now observe. These two are merged. So with 4 elements. So this will be like 7, 8, 10, 19. This is not void. These two are merged and these also not void, you can check. 25 and then 31, 35, 41. So finally, these two are merged. These two are merged. And you can see this will come and then this will come. So this is another void operation. So 1, 2, 3, 3 void operations. That's a very simple question. Answer is 3. Answer is 3 void merge operations. Chalo, next. Let G be a weighted directed acyclic graph with m edges and a vertices, v vertices, n vertices. This should be n and n vertices. Given G and a source vertex S in G, which of one of the following option gives the worst case time complexity of the fastest algorithm to find the length of shortest path from S to all vertices that are reachable from S in G. So it's a directed acyclic graph. It's a DAG, and we are working on the problem of single source shortest paths. Single source shortest paths. The algorithm for this is a two-step algorithm. You have to find a topological order of this. Topological order. And then you have to carry out the relaxation process on the edges. On the edges. This is the algorithm for it, two-step algorithm. And this time complexity of topological order is n plus m, and this is order of m. So adding these two together, the best possible time complexity, the fastest algorithm will be theta of n per n plus m. So that's the answer. Very simple question. Okay. Next. Consider an array of integers of size n. The indices of a run from 1 to n. An algorithm is said to be designed to check whether a satisfies this condition. For all ij in the list 1 to n minus 1, for I greater than j, a of I plus 1, like we have an array, this array A, and these are some n elements, okay, like 1, 2 up to n. So it should be in this order. I will be here, j will be here. For I greater than j, this condition should be true. That means the difference of the elements for I should be I and I plus 1 should be greater than the difference of the elements of j and j plus 1. So an ideal algorithm for this is, you have to find what is called a difference array with n minus 1 elements. Difference array with n minus 1 elements. 1, 2, 3 up to n minus 1. Difference of these two elements should be here, difference of these two next elements should be here, difference, and like that you should see. And this difference array, after you find for n minus 1 elements, this is a difference array of the n minus 1 elements. If this is in increasing order, because difference array you can find, for example, in order of n time, and of checking whether this difference array is in increasing order or not will satisfy this condition. So if this can be done, both steps can be done in order of n time. So the overall complexity of the algorithm will be order of n, will be theta of n. A very simple question. So this is also in theta of n time. And this is a question based on dynamic programming. It's like computation of the table of LCS or computation of the table of 0-1 knapsack or even sum of subsets. It is exactly like that. Okay. So the computation is carried out for all rows and columns it is 1. And non-rows and non-first row, non-first column is basically this computation t of I minus 1 comma I minus 1 j plus 3t of I comma j minus 1. So that is being done exactly in this algorithm B1, the computation of that. So the condition is there are two algorithms B1 and B2 is here. Assume BK for 1 and 2 is said to be correct if and only if you calculate the correct values of Tij. So algorithm 1, that is B1, is exactly computing in based on the recurrence, so definitely it is correct. And for this also it will compute first in row order and then column order, so both will basically be correct. Both the algorithm will be correct. So therefore the correct response for this is B1 and B2, that is option A. What you can do is even take some value of n and then make a simple table, n equal to 4. Then 4 rows, 4 columns, 5 rows, 5 columns. Then basically you can make a computation and you can see that for both of them it will work out. So the correct answer for this is option A, both working out correctly. That's it.